Good evening, my dear JEE 2025 warriors. Welcome all the CBSE students for your guest paper. Yes, this is not a PYQ, this is a CYQ. That means your current year question. This is one of its kind session because we are going to make a guess. Obviously, this is like for your practice. This is just to make you prepared for the actual examination. And we hope that these kind of models will come in the upcoming test. Welcome aboard, everyone. Hi, Ishwar. Hi, Renu. Hello, Hariram, Harni, Haritiksha, Marthan, Cat. Good evening. Just a random channel. Welcome, Akshaya. Hi, Sriram. Nice to see all of you on the channel live. And welcome aboard, all of you who are asking for marathons, PYQs, or basically guest papers, short revision. So here we are on the channel. I hope I'm audible and visible to all of you. Yes, I think I am. Okay, yes, I'm live. Perfect. Quickly smash that like button right away, right now, in case you have forgotten to do so. And yes, hi Pramod. I'm very good. Yes, CYQs. Isn't it a killer name? Hi, Gokul. Yep. If you want, Sanjay, a complete revision kind of a thing, we will try to do it in terms of question practice, because just doing theory is not enough. Because let me tell you, I have already made a video on that. The paper is going to be tough. Okay, I have already made a video on the channel. The paper expected to be on the tougher side, and that's why I have created all these sessions for all of you so that you can quickly revise. Tomorrow, and if possible, today only, if possible, we will do another session of numericals, then case studies, assertions. If you want that, after the video is over, after the session is over, leave a comment. Yes, sir, we want more numericals and case studies and assertion reason. I'll conduct special sessions for that. Okay, so that's your Captain Shreyas, and that's the power of your Vedantu J English, the #1 J English channel in the country. Quickly smash that like button and subscribe to it. Okay, so here it comes, the first section, section A, which is MCQ assertion reason. First question on your screen now. Here it is. Uniform electric field is going in the x direction, and it is in this complete region, let's say, and A is the origin, B is the point on the x-axis, C is the point on the y-axis. Then compare the potentials of point A, B, and C. Let's go. Hi, Prakash. Thank you so much. Yes, video and graphs. Definitely. Definitely. Okay, we will do that as well, or maybe a revision on graphs. Let's see. I will try to squeeze in as many live sessions as possible. Okay. So think, guys, this is your y-axis. This is basically your x-axis. Okay, fair enough. Now, where is that point A? Point A is basically the origin. Point B is on the x-axis somewhere over here, and point C is on the y-axis. Okay, so that is what it is. Okay, so this is your y-axis. And where is the electric field? The electric field is in this particular region along the x-axis. Electric field always goes from high voltage to the low voltage. That means this is an equipotential line. The y-axis itself is an equipotential line. So VA must be equal to VC, and this should be on the higher side as compared to VB. So VC is more than VB, or VA is more than VB. That gives me only option B. Rest other options, VA and VC are equal. VA and VC are equal. Of course, VA is more than VB, not less than VB. So option B. Very good, Ishwar. Naveen, awesome. Great, great, great. Option B. Most of you would have solved the sample paper either in school or maybe even in your crash course, right? So that's the reason why I'm not taking exactly the sample paper. But if you want, we can discuss some of the questions which you have doubts in. Maybe you can put those questions. I will take it up as a practice thing in one of our sessions itself. Okay, because usually the sample paper, most of the students solve it much in advance. Anyways, if you have doubts, please let me know. I will take up those questions as a part of my class itself. In a series LCR circuit, the voltage across the resistance, capacitance, and inductance is 10 volt. Then the capacitor is short circuited. Then the voltage across the inductance will be. Voltage across the inductance will be. The capacitor is basically short circuited, my dear students. Think about it. Think about it. What should be the correct answer? Now, see, guys, you had resistor, you had capacitor, and you had inductor. They are all together connected to this particular AC source. They all had 10 volts, this is also 10 volts, and this is also 10 volts. The voltage across resistance, capacitance, and inductance is 10 volt each. The capacitance is basically short circuited. Now, the moment you short circuit the capacitance, it's as good as saying the capacitor does not exist. Okay, so you just have the resistor, and of course you have that particular inductor with that same source, of course, Now think about it. What will happen in this particular scenario? Okay, what will happen in this particular scenario? The reactances and the resistances won't change. Neither will the total voltage change. So what will be the total voltage in this case? This is clearly, voltage across the resistor will be horizontal in the direction of that current. Voltage across the inductor will be vertically up in the phasor diagram. Voltage across the capacitor will be vertically down in the phasor diagram. These two will cancel out each other. So this 10 volts will then become the net voltage. So 10 volts is basically the net voltage, my dear students. So now over here, basically what will happen is this will again remain as 10 volts. This will again remain as 10 volts. Now the voltage across the inductance is asked. Now what is the voltage across this particular inductance is asked? Very interesting question. Please understand, if all the three were the same here, if this was 10, this was 10, this was 10, it also means one more thing, that the resistance was equal to the inductive reactance was equal to the capacitive reactance. So over here also the resistance will be equal to the inductive reactance in this scenario as well. That means if the voltage drop across this is V1, the voltage drop across this is also going to be V1, but they will not be in the same phase. So if voltage across resistance is horizontal, voltage across inductor will be vertical, and their total voltage will be 10 volts. The net voltage will be the 10 volts. So therefore 10 square will be V1 square plus V1 square. That means it is 2V1 square, that is 10 square. So V1 square will be 10 square by 2. Therefore V1 will be 10 divided by root 2, which is option C. And many of you got the wrong answer. You said B option, isn't it? That is the reason why you should attend these classes. Many students will make this mistake. Got it? Yes, it is C option, it is not B option. So I'll repeat what happened. Okay, it will take you some time to accept this. You guys just thought this is 10, this is 10. I'll just add both of them, 10 root 2. Pythagoras, no. Many people make that mistake. See, current is same, voltage is same, so resistances or reactances will be same. That's why R, XL and XC are same, correct? I drew the phasor diagram. Resistance is always horizontal, inductor's voltage is vertically up, capacitor's voltage is vertically down. They will eventually cancel because they are treated like vectors. Voltages are treated like vectors in phasor diagram, and whatever is remaining is 10 will be the total voltage. So that's how I was able to find this. The source will still remain the same, so that is still 10 volts, but now they will develop new voltages because new current will be formed. New current will be formed in the circuit because the impedance, everything has changed, correct? So what will still remain the same though is the resistance being equal to the inductive reactance. So R will be still equal to XL. So that means if R is the resistance is the same, current in series is the same, voltages, the new voltages, it will no longer be 10, it will be some new voltage. Those voltages will also be the same. Okay, so I will draw the phasor diagram. Voltage across the resistor horizontal, voltage across the inductor vertically up in the phasor diagram. Their resultant will be the net voltage, which is 10. So this square plus this square is this by Pythagoras. So naturally solving V1 will be 10 by root 2. Now did you get it? Is that absolutely clear? Kevin, understood? Got it? Isn't it an amazing question? Isn't it an amazing question? Quickly let me know in the chat box. How many of you got fooled in this particular question? Yeah, Anya, will probably take 1.5 to 2 hours easily to solve the entire question paper. Got it? Yes. Awesome. Let's move. to the next question. A long wire of circuit. See, in your multiple choice question, expect some 2 to 4 questions of higher level thinking. So this is one of that question which was of higher order thinking skills, HOTS questions. Okay, cool. Next question. Long wire cross section carries current. The current is distributed across the cross section. The ratio of the field at a point a by 2 above the surface of the wire and to a point a by 2 below the surface of the wire. Okay, so let's understand what is exactly happening here. So this is basically your wire. Okay, and of course it is carrying current everywhere. Okay, it is carrying current throughout that particular cross section like this. It is carrying current here, it is carrying current here, it is carrying current here. And the question is, find the ratio of the magnetic field at a distance of a by 2 above and a by 2 below. This is below, so a by 2 below will be over here. So this is basically a by 2, and then a by 2 above will be outside. A by 2 above will be outside. But remember, all the distances have to be measured from the axis of that wire. So this is that axis of the wire. So truly speaking, if the radius of the wire itself is given to be A, if the radius of the wire itself is given to be A, so this distance A minus A by 2 will be basically A by 2. This is A and this is A by 2. So technically speaking, this whole distance which is there, A plus A by 2 will become 3A by 2. This is above and this is below. Now magnetic field above, that will be the same as the magnetic field outside the wire, is mu naught I by 2R. Mu naught I by, 2 pi R. 2 pi R. So it will be mu naught current divided by 2 pi radius. Radius is the distance in this case, which is 3A by 2, which is nothing but 3A divided by 2. Everybody fine till this point? Everybody fine till this point? Clear? Okay. Now what is next? What is next? Okay, some of you have solved this previous night. Okay, very good. Next, inside. Magnetic field inside has a formula, mu naught current distance from the axis square by your 2 pi radius square. So it will be mu naught, my bad. Sorry, this is just R on the top. R square is only there below. So mu naught current, small r is the distance, which is nothing but A by 2 divided by 2 pi R. R is the radius of the wire, which in this case is A square. So this will just become mu naught I, AA cancels, 2 pi multiplied by 2A. That is what it will be. Now you just have to take the ratio of outside by inside. You just have to take the ratio of this divided by this whole thing. So that particular ratio which you want will be mu naught current by 2 pi multiplied by 3A by 2 and divided by this whole thing. So mu naught into current divided by 2 pi multiplied by 2A. Mu naught I, 2 pi, A cancels. I think 2, this below will go on the top and 3 will be remaining below. So it will be 4 by 3, I believe. So 4 by 3 is option number C. Yes, it is the correct answer. Beautiful question. You just need to know these formulas. It is there in your NCERT. Magnetic field outside versus inside after Ampere's law, it has been derived. Yes, it is there. Hello, Sasi. Good evening, my dear warriors. And yes, mu naught by 2 pi. Yes, just a random channel that not looked like very naughty to me. Oops. Yeah. Yeah. Anyways, moving on. The diffraction effect can be observed in, this is a straightforward question. This is not HOTS. This is straightforward. This is straightforward. Okay, Sahiti, no problem. I will go slow if you want to. Diffraction effect can be observed in sound, ultrasonic, light, sound as well as light. Now, diffraction is a wave phenomena. All kinds of waves can diffract, and diffraction means spreading of light. When it goes through a hole, instead of just continuing going straight and not going into the shadow, rather it spreads even into the shadows. And even if there is a corner, you would expect the light to go straight and not bend over, but actually light bends. Even sound, ultrasonic, everything bends. So that is true for everything. Sound waves, light waves, any kind of waves. Derivation is not so important. Only few things, I mean, by the way, I don't know how many of you know this. On the channel itself, I have done all the derivations. If you want, I will share a link of all the derivations. Do you want me to share that particular link? I have done derivations for CBSE properly, okay, over here. If you want me to do it, no issues. I will make a small video on that, and I will give you all the derivations line by line properly for CBSE perspective. Definitely, I will do that. Okay. Next question coming up on your screen. Next question coming up on your screen. The distance of the closest approach of an alpha particle is d when it moves with a speed v towards the nucleus. Another particle is projected with higher energy such that the new distance is d by 2. What is the speed of projection? What is the speed of projection of that particular alpha particle? What is the speed of the projection of this particular alpha particle? Very interesting question, my dear students. See, what happens is that if you have this particular alpha particle, it has been thrown with certain speed. Slowly it decelerates and finally it stops. Finally it stops. And when it stops is what you have, that least distance, least approach, least approach distance, least approach distance from that particular nucleus, from that particular nucleus. So what happens is all your kinetic energy gets converted into the potential energy. All the kinetic energy gets converted into the potential energy. All right. So the formulas which usually go for it is as follows. So whatever your kinetic energy which is there, the kinetic energy which is there, that will be nothing but half m into v square will be converted into the electrical potential energy, because the speed becomes zero, kinetic energy vanishes. So the potential energy will be Coulomb's constant K into charge 1, let's say the charge of the alpha particle, into charge of the nucleus, divided by the closest distance of approach, which is basically d. So this is the equation. This is basically the equation. From this, can you not see k, this charge, mass 2, everything is a constant? Oh my god, who is this? Ramachandran. Thank you so much, my dear. I'm so glad for all your love that you have shown. Thank you so much, yeah. You deserve to be shown here. Thank you so much. Thank you so much for that super chat which you have given of 100 rupees. Thank you so much. Means a lot. Means a lot. Yeah. So from this, can you see, my dear students, everything is a constant except for speed and d. Everything is a constant except for speed and d. So can you see v square is proportional, inversely proportional to d. Speed square is inversely proportional to d. Can you see that? Okay, very good. Everybody is able to see it. So now think about it. Speed is given, distance is also compared. So that's all the question is all about. So I will just write that I want to find the new speed of projection. So the new speed by that old speed whole square will be equal to the new distance, old distance, inverse ratio. That is what it will be. V2 by V1, this will be D1 by D2 because it is inversely related. What is the old distance, first distance? It was basically D. The new distance is basically d by 2. As you can see over here, the new speed is what I want to know. The old speed was basically v over here. So square this. As you can see, this will become v2 square by v square is equal to 2 will go on the top, 2 will go on the top. So v2 square will be v square multiplied by 2. So v2 will be root 2 multiplied by v. v2 will be root 2 multiplied by v. Is that Yes, is that absolutely clear? Everybody with me? Root 2 multiplied by V. Some of you gave the wrong answer saying 2V. No, it is not 2V. It is option B. Beautiful question. Yes, beautiful, beautiful question. Amazing. Loved it, guys. Shall we go ahead? Okay, clear? So what was the concept here? Kinetic energy getting converted into potential energy. Kinetic energy half mv square. Potential energy k q1 q2 by distance. As you can see, everything is constant except for speed and distance. So they are inversely related. I just wrote down the ratio form and I substituted all the values given in the question. Immediately solving it, I got the answer. Moving on. Point object is placed at the center of a glass sphere. Refractive index, distance of the virtual image from the surface of the sphere. This is not even HOTS, this is direct. You don't have to solve it so much. Okay. I am so glad bottle money. Yes, it is very true. I mean, more than any money, I just deserve your support. I just deserve your love. I just deserve your comments. I just deserve your word of mouth because we are doing it all for all the South Indian students. We started this channel because all the students in major cities of our country study in English medium. Or majority of the students in South learn in English medium. Many students in UAE are CBSE students and they learn in English medium, and we wanted to create a quality channel, and that is the reason why we are doing this for you. Correct? So what do you think the answer is? Some of you are saying C, and is there somebody else saying any other answer? Okay, so best way to look at the problem is drawing this particular diagram. Drawing this particular diagram. And see, guys, the radius of the curvature is how much? 6 centimeters. And the object is placed at the center. Oh, so this itself is 6 centimeters, the radius. And you have placed an object here itself. So this is where your object is. If you show me the rays coming out of it, it will be very easy. One ray will directly go via the principal axis. Any other ray will be normal only. In fact, any other ray also you draw, it will be like that only. In fact, all the rays will be just chumma perpendicular to the surface. So they won't deviate, they won't bend. It will feel as if the image is also over here only. It will also feel the image is coinciding on the object at a distance of 6 centimeters. Yes, so it is at a distance of 6 centimeters. This is the surface and this is also 6 centimeters. So that is option C, because the rays did not bend because of normal incidence, because of, yes, angle of incidence being 0 or perpendicular to the surface. Is that absolutely clear? Yep. Awesome, awesome. I'm not sure which state board you're talking about, but if the syllabus is very much similar, difficulty is more or less the same, definitely it might help you in your state board exam, but nevertheless, it will help you for your JEE also. Colors observed in a compact disc. If I say CD, people will think, what the hell is CD? Now, I know you guys are Gen Alpha, or yeah, most of you are Gen Alpha only, I guess. So you might not necessarily know a CD. Maybe this question might not be so relevant to you. Maybe for Gen Beta students, this question will not come. Okay, so a compact disc. Why do you see different colors? So I need to show you what a compact disc looks like also. Yeah, yeah, the answer is reflection, diffraction, dispersion, or absorption. The answer is there are small gratings, small openings in a compact disc, and these small openings, it will act like apertures or slits. And when light falls and reflects, you will see that the light will will diffract from all these small openings, which then cause interference and thereby giving you those different colors. So that is a diffraction. This is a compact disc. You can see the different colors. This is because of the interference after the diffraction which occurs. So a lot of white light is there. White light will fall onto the small openings which you can't see in your with your naked eye, but it is there, and those openings will cause the bending effect of light, which is diffraction. Okay. Okay. Awesome. 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 Great. Moving on to the next question. If copper wire is stretched to make the radius decrease by 0.1%, then the percentage change in the resistance is how much? Okay, let's see. If you take a wire, and you stretch it, if you stretch it like this, obviously the radius decreases. That's why the length increases, the radius will decrease. That is what happens. So in this process, what happens is the volume is constant. Volume is basically going to be constant, and volume is nothing but pi r square, which is the area of the cross section, multiplied by the length, which is definitely going to be constant. So therefore, L will be some constant, which is basically the volume, divided by pi into r raised to minus 2. Is that right? L is nothing but constant by pi, and r is raised to the power negative 2. Radius has been decreased by 0.1%. Therefore, delta L by L will be delta R by R. Power is negative 2. Always take the modulus of the power, mod value, even if it is negative. So therefore, if I convert this into percentage, the change in the percentage of the radius is 0.1 multiplied by 2. So length has changed by 0.2%. So the percentage change in the length is 0.2%, which I will need for the calculation purposes. I will keep it on the side. Now I will come to the main part of the question. The resistance is rho L divided by A. Rho L divided by A, resistivity into length divided by area. Area is pi r square. So basically this is a rho L by pi r raised to minus 2. So the relative change in the resistance is rho and pi are constants. Delta L by L plus 2 times delta R by R. Now, what is the change in the length? Well, it is 0.2%, of course. What is the change in the resistance? It is basically 0.1%, of course. So 0.2 plus 0.2 will make it 0.4%. So that is the change of the resistance, which is 0.4%, and resistance would have increased because length has increased and the area of cross section has decreased. So resistance will increase, not negative. Take it as positive. Don't mark A. Although the magnitude is the same, negative no. Why negative is incorrect? Because it has not decreased, it has increased. So the concept of error combination is involved, and the concept of resistance measurement along with volume conservation is also involved. Remember, the concept of errors goes like this. Whenever you express anything in the form of powers and there are some constants, the relative error has to be found by ignoring the constants and take the relative error in each quantity, and whatever is the power will be multiplied by the relative error. As you can see over here, I have expressed it in the power formula. Length is raised to 1, R is raised to minus 2, resistivity and pi are constants. I have completely ignored in the next step. So the relative error in the resistance is relative error in the length. Length's power is 1. So that's why I can just multiply 1 over here. Radius's power is minus 2. Take the mod value. So 2 into relative error in the radius. So that is the concept of errors, which was one of the first chapters of 11th standard. Is that absolutely clear? Yes, everybody with me? Okay. So these are some really good questions, my dear students, or else you will think and expect that CBSE paper is laddu paper, but it is not laddu paper. Please understand that. Go with a mindset that it is of JEE mains level only. Okay, NTA is only going to like set it. Go with that mindset. Don't take it casually. Else, if you do not get 75%, you will not be eligible for top government colleges. Please remember that. Magnet of moment M is suspended in a field. Maximum value of the torque acting on the magnet is. What's the maximum torque on the magnet? Yes, come on, my dear students. Come on, my dear students. Think about it. Think about it. Yes, come on, my dear students. What do you think are the question? What do you think is the answer to this particular question? The torque value is mv sine theta. If I want to make the torque maximum, I should make sine theta maximum. And the max value of sine theta is 1. Hence, the maximum value of torque will be mb into 1, which is just mb. So, mb, which is B option, this is direct question, direct answer. Yep, option B, everybody has spammed it. Very nice. B. No, it is not A. It is B. Very good. Very good, Saiti, Akshaya, Rishika, Kumar, Pramod. I see. Yes, very good. Very good. Awesomeness. Moving on to the next one. What is the unit? What is the unit of permeability? What is the unit of magnetic permeability? Come on, my dear students. Magnetic permeability. Try to think of some formula which will help you with the answer. Magnetic permeability. Yes, is there any formula which will easily give you the answer? I think it will. Yes, come on. The PDF will be available later on. Vanakkam, vanakkam. Yeah. Minimum will be 0, Saiti. Minimum will be 0 because sine theta's minimum value is 0 magnitude wise. So magnitude will be minimum and that will be 0 when either the angle is 0 degree or 180 degree. Okay. So I think the best formula will be magnetic field is mu naught number of turns per unit length into the current. So mu naught will be magnetic field into the length divided by the number of turns into the current. Now let's talk about the units. Magnetic field is in Tesla, length is in meter, turns does not have a unit, and this one is in ampere. So that should be the unit of mu naught. Tesla meter per ampere. Tesla meter per ampere is option D. Very good. Awesome, my dear warriors. Can I use mu naught Ni? Yeah, that is what I have done. Mu naught Ni. That's what I have done. Yeah. This is, which formula is this? If you have forgotten, this is the field inside a solenoid. Field inside a solenoid. So whenever you don't remember units, try to remember some formula which can be easily used to find the units. In this case, this was the formula which proved to be useful. The output of the logic expression A bar plus B bar. Very interesting. A bar plus B bar is what? A bar plus B bar can be expressed in the simple form as, come on, my dear warriors. Yep, think about it. Well, I will tell you, this comes from something called as the De Morgan's principle. Even though it might not be directly mentioned in NCERT, this is something which you should know, and it is useful for your NEET, JEE, CBSE, all competitive exams. They can challenge you like this. This can be a very good question. A bar plus B bar, if you want to know. See, this is actually when the bars are separate, you can combine them together and you can then replace that plus with a dot. You can combine the bars together, but then replace the plus with a dot. Also, the same thing works for if it is A bar dot B bar, the bars are separate. I want to put a common bar, then put A, the dot will then become plus. Both of them work. This is basically your De Morgan's formulas. De Morgan's formulas or rules. So in this case, A bar plus B bar separate is A dot B's whole bar, which is option A. Yes, sometimes they can also give you the logic gate information as well. Okay. Energy stored in a capacitor and dissipated during the charging of a capacitor is in which ratio? Very important question, my dear students. Yes. Yeah, I know. Deleted maybe, but yeah, still useful in JEE NEET. Okay. So what is the energy stored in a capacitor and dissipated during charging of a capacitor? Come on. If you take a capacitor and connect it to a battery like this, then the energy stored in the capacitor is half CV square. The work done by that battery comes out as CV square. The energy which is lost is exactly again half CV square. In fact, you can see both of them when added give you basically this. So whatever battery does, if it does 100 joules work, 50 joules is stored in capacitor, 50 joules is lost. So the question asked is, what is the energy stored in the capacitor versus dissipated? So you can see both the terms are the same. So it is 1 is to 1. So 1 is to 1 should be the answer, option number A. Excelente. No, it is not B. I don't know why you said 1 is to 2. Guys, 1 is to 2 will be the answer for capacitor is to work done by battery. Get it right. Capacitor's energy upon the work done by battery. This is half, this is 1. So that ratio will be option B, which is 1 is to 2. But work done, energy stored and heat lost, both are equal. So hence it is 1 is to 1. Got it? Don't make such mistakes. I can see majority of you made some mistakes, at least in some critical questions, 3 mistakes, 2 mistakes, 4 mistakes, that will easily suck away 4 marks to 3 marks, which means you need to be extremely careful. You might take objective questions very lightly, but that's exactly where you might lose marks as well. Okay. Now remember, assertion reason type of questions are also there. So think about it. Assertion, reason, both are correct, wrong, correct, explanation is correct or wrong. All such of options are there. On increasing the current sensitivity of a galvanometer by increasing the turns may not increase the voltage sensitivity. The resistance of a coil of a galvanometer increases on increasing the number of turns. What do you think is the correct answer? Yes, what do you think is the next answer? Come on, come on, come on, come on. No, Yugant, all the work done is not stored. Only half of it is stored, half of it is getting lost. Yeah, that is also there in your NCERT questions. You can check it out. So let me tell you, my dear students, what should be the answer for this particular question? Yes. What should be the answer for this particular question? Come on, come on. If you increase the number of turns, resistance is directly proportional to the length. Length of the wire will increase because the number of turns has increased. So the resistance will increase. So reason is definitely correct. Now there is a formula for sensitivity. Just like V is equal to IR, I is equal to VR. Sensitivity of current is equal to sensitivity of voltage multiplied by resistance. So sensitivity of voltage is sensitivity of current divided by resistance. Now this current sensitivity is directly proportional to the number of turns. So if somebody increases the turns, sensitivity of current will increase, but even the resistance will increase. So guys, numerator is increasing, denominator is also increasing. Does not mean this ratio will, does not mean the ratio will increase. So be careful about it. So it may not necessarily increase it because both numerator and denominator are increasing. So even this is correct, and this can be only explained because in the denominator resistance increases, which creates the doubt. If this denominator was not there, then increasing the turns will increase the current sensitivity, thereby increase the voltage sensitivity. Then there will be no word like may. It will definitely increase. The problem comes because of the resistance. Hence, the ambiguity arises because of this statement. Hence, this is the correct explanation. It is explaining it. So it should be option A, I believe. Yes, it is option A. No, it is not B. Yes, it is not B. It is A only. Many of you got it wrong. It is explaining it. See, if the second statement was not there, right, then this word may not would not have come. It would be, it will increase the voltage sensitivity if this denominator was not there. But because of this, there is the doubt. Numerator increases, denominator increases. So what will happen to the voltage sensitivity? It may not necessarily increase. That is the problem. Okay? Freaks, just practice questions now. Don't be scared. I mean, just practice, practice, practice. Whatever marks you can get it. I will give you tips also on how to boost your marks at the last moment. A step-up transformer can't be used as step-down. A transformer works only in one direction. Is this true? What do you think about this? What do you think? What do you think, guys? Yep. Yes, think about it. Think about it. Step up can't be used as step down. Is that so? No, if you pass the voltages in the reverse direction, instead of the turns increasing, the turns will decrease, voltage will decrease. So it can definitely be used. So this word cannot is wrong. Transformer works in one direction. Who says? If you reverse the directions, everything instead of input will become output, output will become input. So it works only in one direction. Wrong. It works in both the directions. So both are false, I believe. Both the statements are false. Just check this out. Both the statements are false. E option is the correct answer. Very good, Louis Ishwar. Sasi, awesome, awesome. Saswin, very good, Sriram. Very good, unknown. Deepansh, awesome. Very good, Vikrishi. Very good, very good. Let's move to the next question coming up on your screen. In a hydrogen atom, there is only one electron, but the emission spectrum shows many lines. Reason, in a given sample of hydrogen, there are many atoms, each containing an electron. Hence, many electrons in different atoms may be in different orbits. So, many transitions from higher to lower orbits are possible. Shall I give you an easy hint? The easy hint is whenever such big statements come, no examiner will write such big statements if they were false. Usually, when very big statements come, usually they are true and they won't waste your time. Generally, this is just like a trick. So this is actually going to be true and it will be also explaining it. So it is option A. So it is actually proper explanation. See guys, what happens when many atoms are there? Every electron might be in different excited energy levels. One is in first excited, one is in second, one is in third, one is in fifth. So when these excited electrons come down, they will emit photons of different wavelengths and different frequencies. That's why you don't get one line, but you get many lines. So yes, it is explaining it. And that's the reason why hydrogen atom, even if there is one electron, you get many lines. Did you understand the trick and also the explanation? Okay, you can use that trick for certain questions. Even in JEE NEET it works, by the way. The photoelectrons produced by monochromatic light beam incident on a metal surface have a spread in the energies. The electrons are emitted from inside the metal surface is lost in collision with the other atoms in the metal. So, say for example, this is our metallic surface. This is our metallic surface. Light will fall onto it. Light is going to fall onto it. Light is going to fall onto it. This is incident light. What will happen? These electrons, they will be emitted with full energy, but they won't directly come out. They might collide somewhere. They might collide here. They might collide like this. They might collide like this, and then they will come out. Some electron might be very lucky. It will probably undergo just one collision and then directly come out. Some electron might be even more lucky just at the surface and it comes out directly. Another electron might collide here, then collide here, then collide here, and then collide here, and then maybe come out like this. So there is a range of kinetic energies. In fact, the kinetic energies range is 0 to basically E times Vs. So that is the range of your kinetic energies. And this EVS is sometimes also called as Kmax. And that is because of the collisions which occur within the atoms before they come out. So it is correct explanation of it. And yes, option A is the correct one. Did you write A? Very good, Aditya. Ashmon. Yes, Vanakkam, Sriram. Awesome. Okay, very good, Dia. Very good, Arjun. Frickles, just solve questions. And if there are these high weightage chapters, please watch the one shots. Okay, please check out the video which I have made. Okay, this particular video which I have made. Okay, these one shots, go through the chapters, and I have given the complete strategy for tough paper. Okay, I would be very happy if the paper is easy, but in case if it is tough, complete topic names, everything I have mentioned, what you should be doing. Check that strategy out. Section B, guys. Yes, in answer in some 1-2 lines, those kind of questions. Okay. Uniform magnetic field gets modified in material X versus material Y. Identify the specimens and also give the reasons for it. I want everybody to put the answer in the chat box. Which material is X? Which material is Y? I'll tell you, the tricky part is material Y. Many students are going to make a mistake in material Y. Yeah. Okay, so K is nothing. We'll be doing it very shortly. Don't worry. Yeah. I'll be informing you, but obviously tomorrow morning and then again tomorrow evening, all classes will happen. Yeah. All right. Harish Rajani, welcome. Okay. See, first is very obvious now. Because the field lines repel, the field is repelled. This only happens in diamagnetic. in diamagnetic substances. So 100% X has to be diamagnetic. Okay, 100%. But the problem is with Y. Is it para or ferro? Is it para or ferro? Let's see. Many people are saying ferro. Why not para? Both in para and ferro, the magnetic field increases. So how do you know this is para or ferro? See, all the field lines are getting concentrated over here. The field is heavily concentrated, and concentrated, because of this, it is a ferromagnetic substance. It is a ferromagnetic substance, which is why. If it was, if it was paramagnetic, right? If it was paramagnetic, then the field lines would look something like this. The field lines would look probably something like this. Something like this. So actually, this is not the right way. Sorry, guys. It would look something like this. Some field lines will not be able to come inside, and it will not be so concentrated. So that's what it will be for paramagnetic materials. It will not be so heavily concentrated. Is it okay, everyone? Absolutely. Yes. Okay. Dia and ferro. Moving on to the next question. I think this is a numerical based question. Okay. So I want you to help me out with the calculations. Okay. Come on, my dear students. Think about this particular question. Okay. Alpha particle is passing through a voltage on a silver foil. Atomic number is given. Find the kinetic energy. Find the energy of the alpha particle at this distance and the shortest distance. Three questions are there. So maybe I'll put three duplicate slides. Okay. So first part, what is the kinetic energy? The first part, always write it down like this. The kinetic energy of alpha particle is equal to the charge of that alpha particle, the charge of the alpha particle multiplied by the potential difference of acceleration. The potential difference of acceleration, charge into delta V. The charge of an alpha particle, how much charge will it have? It has a positive 2e charge, isn't it? Positive 2e charge. Do not forget that. Yes, so 2 multiplied by 1.6 10 to the power minus 19 coulombs multiplied by potential difference already given 2 multiplied by 10 to the power 6 volts. So this is 2, this is 2 becomes 4. 4 into 16 is 64, but it is 1.6. So that means it will be 6.4. So this will be 6.4. Okay, minus 19 and plus 6. So this is going to be 10 to the power minus 13. Yes, everybody? Very good. How many of you wrote it? Very nice. I can see many of you giving the correct answers. That is the correct answer. Very good, Sahana. Very good. Very good, Nikhilesh. Yes, plus 2e. Yes, this Gokul. Very good, Adam. Excellent. Excellent. Let's go to the second part. Now, the kinetic energy of the alpha particle at this distance, I'll make you visualize this. This alpha particle had this 6.4 into 10 to the power minus 13 joules of kinetic energy. What happens now? It begins to decelerate. It's not completely stopped. It still possesses some kinetic energy here. And now this alpha particle is at a distance of how much? 5 into 10 to the power minus 14 meters from some nucleus. From some nucleus. Yes, from some nucleus. Nucleus of silver. Yes, so this is basically silver. This is basically silver nucleus. So this is a positive ion. Remember that. So the question is, what is the kinetic energy here? Use conservation of energy. That's all. So the kinetic energy which is there initially will be converted into some amount of kinetic energy will be remaining finally, plus some potential energy at that distance. Now, this kinetic energy which will be there finally will be this minus this. So, kinetic energy which is there initially minus this potential energy. What's the formula? It will be 1 by 4 pi epsilon naught charge 1, which is 2e, multiplied by the charge 2. It is silver of 47 atomic number, so 47e, q1 q2 divided by the distance, so we know this particular value is nothing but 6.4 into 10 to the power minus 13 joules, minus, substitute everything guys, 9 into 10 to the power 9, 2 multiplied by 1.6 into 10 to the power minus 19, multiplied by 47 multiplied by 1.6 into 10 to the power minus 19, and the whole thing divided by distance, which is 5 into 10 to the power minus 14. Substitute everything and you will get some number over here. Just check out what that number is. See if that number is 4.33 10 to the power minus 13. See if it is 4.33 into 10 to the power minus 13 joules. And you have to subtract that from 6.4 into 10 to the power minus 13. So therefore, you will then get that final kinetic energy. This minus this. Come on, do this. Yeah, it will be 4.33. Just check it out. Yep. Come on. 6.4 minus 4.33, 6.40 minus 4.33. Come on, how much will it be? Yeah. 2.07. 2.07, everyone? Yes, 2.07. 2.07 into 10 to the power minus 13 joules, everybody? Yes, that is the correct answer. Very good. Awesome. You can approximate it as 2.1 also. That's fine. Many of you are saying 2.1. That's okay, guys. No issues. But yeah, the more exact number will be 2.07. Okay. Now let's go to the third part. So this was the second part which we just did. Now the third part. Third part is very similar, just that the only difference is this alpha particle, which had 6.4 10 to the power minus 13 joules, will decelerate and completely stop. And that stopping distance question, and it has stopped near that silver nucleus, and we have to find what that stopping distance is. So basically, that kinetic energy which was there initially, which is 6.4 10 to the power minus 13 joules, will be completely converted into potential energy, because nothing is there in kinetic, and potential energy is 9 into 10 to the power 9, which is K. Charge 1, which is alpha particle, which is 2 into 1.6 10 to the power minus 19. Charge 2 of silver, 47 into 1.6 into 10 to the power minus 19. Whole thing divided by D. Solve this, you shall get the answer. Yes, solve this. D is on the top. Bring these people over here. You will get the answer. Yep. Is that clear, everyone, how to do this? Yes, is this absolutely clear? I think that distance comes out 3.38 10 to the power minus 14. Yes, just check it. 3.38 into 10 to the power minus 14 meters. So that is your third answer, which is the closest distance of approach. Okay. Clear? Energy conservation and the question on electrostatics. The formula used over here, was K Q1 Q2 divided by R. K value is 9 10 to the power 9. Q1 is 2e. Yes, this is basically 2e. This is 47e divided by that distance. Okay, this is the value of the K. Cool. Everyone? Sorry, electron volt into volt. We don't have to do anything like that. All the answers were in joules only. Please remember, whatever we have found out, everything was in joules. So there was no need of conversion at all. So I'm sticking to SI units in this question. Okay. So there was no need for conversion, Sashwant. Okay. But if you're generally asking, sir, what is the conversion factor? Then here it goes. Say, for example, it is 1 electron volt. Just substitute the value of E. So it will be 1.6 into 10 to the power minus 19 joules. Okay. So from electron volt to joules, you always multiply by that factor. So if it is 10 electron volt, it will be 10 multiplied by 1.6, 10 to the power minus 19 joules. If it is the opposite, let's say it is some 200 joules, I have to convert it into electron volt. So 200 divided by 1.6, 10 to the power minus 19. This will be in electron volt. You can see E and E will cancel. So you will get back that 200. So this is the reverse method. Cool. Electromagnetic wave is going in the I cap direction. Electric field is oscillating in the y-axis. The questions are, identify where the magnetic field is oscillating. Second is, magnitude of the electric field and the magnetic field are related to each other by which equation? Very good, Shashwat. Sir, up to how many decimal places should be written? Sahana recommended is 2 decimals, but till 1 decimal, bare minimum, bare minimum. Okay, at least get it till 1 decimal if time is not permitting, but till 2nd decimal is recommended, just on the safety side. But if you are rounding off, or if you are not getting the close enough answer, they will generally not bother you so much till 1st decimal also, usually. Okay, right. Now identify the direction of this. See, the electromagnetic wave is going in I cap. That means this is the direction of the wave. This is the direction of that particular light, which is in I cap direction. The what is electric field is going along y-axis. Electric field is along y-axis. This is the electric field which is in j cap direction. Well, electric field cross with magnetic field should give you the direction of the light. So the magnetic field will be along the z-axis. This diagram, please show it so that they will be full super duper impressed. So the first answer will be, it is oscillating along the z-axis. That is the first answer. Everyone, how many of you wrote z-axis? Very good, Siva Prasad. Excellent. And what's the relationship between both of them? The answer is electric field by your magnetic field is given by your speed of light. Which is 1 by root of permeability into permittivity. This is the formula. Okay, this was not needed. This is just for your extra information. This was not needed. Just even if you write this, you will fully get the complete answer, marks for this particular answer. You mention where E is electric field, B is magnetic field, okay, C is the speed of light. If you do all those things, 100% you will get it. Yes, perfect. Okay, just don't write like this, guys. Please write it in beautiful words. Write it in beautiful words. The ratio of electric field by magnetic field is the speed of light given by E by B is equal to C. Fully how to impress. Who are you impressing? A 5-year-old kid. Who is correcting your paper? Who is correcting your paper? Remember this. Remember this. Who is going to correct your board paper? Who is going to correct your board paper? This person. Who is going to correct it? Who is going to correct it? Yeah. Start with objective only. Yeah. V and C both are the same thing. C is usually the symbol, but you can also put V. One and the same thing. Okay. V or C, one and the same thing, my dear students. Here they have put V. So if they have given V, then we'll stick to V. If they have given C, we'll stick to C. If they have not given anything, you make your own variable, V or C. Yeah. No, it is not Champa, it is Papa Pandu. Okay, Papa Pandu doesn't understand anything. Papa Pandu needs to be explained. Oh, this is how to walk. Oh, this is how to lift your leg. Oh, this is an apple. Oh, this apple is falling down. So think you're explaining to a Papa Pandu. Got it? Everyone? Great. Awesome. Moving on. A beam of light consisting of two wavelengths is used to obtain interference fringes. What is the least distance from the maxima at the center where the dark fringe will be obtained? That means basically the dark fringes coincide. Because if it is completely dark, both the dark fringes should merge together. Is that absolutely clear? Papa Champa. Papa Champa, no. Champa is full Chalu Champa. CC. Chalu Champa. Yeah. Full Chalu Champa it is. Yeah. Papa Pandu, Chalu Champa. PPCC. Got it? Okay. So, Chalu means very country fellow, very cunning fellow. Yeah. Okay. Moving on, moving on. So, yeah, derivations are there. Moving on. How do we do this? First, use the formula for the dark fringe. In general, the the location, or I will just say, uh, where will you get uh, the dark fringes? There is a formula for that. There is a formula for that. What is that formula? First, you should know. Then, once you know that, then you can solve it by a simple equation. So, what is the location of a dark fringe? The location of a dark fringe, the location of a dark fringe is given by y is equal to, you have odd numbers over here, and then you have lambda d by small d, and this whole thing is divided by 2. This odd number can be 2n plus 1, 2n minus 1, anything like that. Okay, so that is what that formula is. Now, since both of them have to coincide, that means for the dark fringes to coincide, what should happen? Think about it. First odd number by 2, lambda 1, capital D by small d, should be equal to the second odd number divided by 2, second lambda, capital D by small d. This is what should happen. 2, 2, D will cancel. So therefore, what should happen is odd number 1 by odd number 2 should be lambda 2 by lambda 1. Lambda 2, what is lambda 2? That is nothing but 6000 Armstrong. Lambda 1 is 4000 Armstrong. Okay, so therefore, I will get the first odd number by the second odd number. What is the ratio, guys? Can you guys quickly think and tell me? Can you guys quickly think and tell me? Yes. Quickly think and tell me what is the ratio of the odd numbers? 6000 by 4000. Come on. What is the ratio? What is the ratio? Zeros cancel. 6 by 4. What is it? 3 by 2. What is it? 3 by 2. Oh, now this is where the most common mistake happens. So people think third dark fringe and the second dark fringe will coincide. Isn't it? That's what you thought? That is what you thought? Is that what you thought, my dear warriors? Okay, better to have a look at the YDSC derivation. I have done that. I will share the derivation video, but chances are 50-50. It may not come, it may come, who knows. Usually it doesn't come, but we don't know. Okay. The problem is, you should realize that an odd number can be 3, but an odd number can never ever be 2. It can never ever be 2. How can an odd number be 2? Think about it. Is it possible? No, right? So, what does this mean? This is not possible. This ratio, if you take any odd numbers in this universe, no odd numbers ratio will be 3:2. It can be 3 by 5, it can be 7 by 9, it can be 7 by 21, it can be something else by some odd number by odd number, but never odd by even. So, not possible, which means our condition which you are trying to find will not happen. Therefore, the dark fringes will not coincide. Dark fringes, therefore the dark fringes won't coincide. Won't coincide. Is this absolutely clear? Is this absolutely clear? No common dark fringe. I have a question for you, just in case. Sir, I got odd number 1 by odd number 2 as 3 by 5, sir. Then is it possible? Then is it possible? Chumma, I'm just giving some random values. Is odd number 3 by 5, is this possible, guys? Yeah, this is possible. Now, this is 100% possible. Both are odd numbers. Definitely. So now, this is which dark fringe? Third, fifth, lot of people are going to make a mistake. Is this the third dark fringe? No. How are the odd numbers, guys, going to be? Your odd numbers are like 1, 3, 5, 7, 9, 11. So technically speaking, 1 is your first odd number, 3 is your second odd number, 5 is your third odd number, 7 is your fourth odd number, 9 is your fifth odd number. This is basically your sixth odd number. Basically, if this is n, then this side will be 2n plus 1. Sorry, 2n minus 1, my bad. 2n minus 1. 2n minus 1. 2 into 1, 2 minus 1. 2 to the 4 minus 1. 3 into 2, 6. 6 minus 1. 8 minus 1. 10 minus 1. 12 minus 1, as you can see. So this is technically the second dark fringe, and this is nothing but the third dark fringe. So the second fringe of the wavelength 1, so second of lambda 1 coincides with the third of the second wavelength. That is what the answer will be. Is this clear now? Manshi, please don't spam. If you have completed 11 chapters, derivations, tomorrow numerical part is enough, and solve PYQs. And please do case studies, Manshi. Please do lot of case studies and numericals. Okay, and also little bit of assertion reason. Acha, you're done already, assertion reason. Great. Understood why the answer for this will be not possible and why for the other modified example will be possible. This can fool many students. Many students will fail in this answer. That is why I have taken it. Give me a thumbs up, and if you have liked these kind of questions, quickly smash the like button, guys. Okay, because I am making you think beyond the box, and CBSE papers are not very easy also. Don't take it very lightly. Okay, shall we go ahead? Shall we go ahead? Next question coming up on your screen. Here it is. Describe briefly with the help of a diagram the role of two important processes in the formation of PN junction. Two processes. Don't say forward bias and reverse bias. No. Sir, paper leak karo. Yeah, Sam, I'll do one thing. I will just give me a second. I will just leak the paper. I'll do one thing. I will just take this. Yeah, I have the paper. I'll do one thing. I'll take this paper. I'll put it in water. And what happens is when you put the paper in the water, no, it will start dripping like this. So the paper will leak. Okay. So that is how you can leak the paper. Okay. Describe briefly with the help of the diagram the role of two important processes involved in the formation of PN junction diode. Yeah. One is diffusion, one is drift. Very good. So now you have to explain it also. You have to show a diagram also. You cannot just say drift and diffusion and expect full marks out of it. No. So in a P and N junction, N has more electrons, majority. Very few holes are there. They are minority. P has more holes, majority. Very few electrons. These electrons love the holes. So the electrons diffuse into the P side. The holes diffuse into the N side. Electrons diffuse into the P side. The holes diffuse into the N side. Because negative is going here, positive is coming here. As a whole, positivity is coming towards this side. So the current is flowing towards this side. This process of two different concentrations, one is electron, one is holes. When they are mixed together, they start to migrate, they diffuse into each other. That is why it is called diffusion. And this current is called as diffusion current, which goes from P side to the N side. As simple as that. Everybody clear till this point? Everybody clear till this point? Very good. Next, diffusion current, because it involves majority of the charge carriers, that's why majority charge carriers participate in the diffusion current. And this process clears a region, creates a region where all the electrons have migrated here, holes have migrated here. Because they have left, it creates a depletion zone. And because then this becomes positively charged, this becomes negatively charged, there is a voltage difference between the N and the P side. That voltage difference is called as the voltage barrier or potential barrier. Is this absolutely clear? Next, once that depletion layer, everything is formed, because N side is positive, P side is negative, from N to P side, electric field will flow. From N to P side, electric field is going to flow. And because of the electric field, there will be force on the charges. On the P side, minority will be electrons. These electrons will experience a force opposite to the field. On the N side, the minority will be the holes. They will be pushed in the direction of the field. Negative going this way, positive going this way. So total current going this way from your N side to your P side. From your N side to your P side. So drift is this particular process which happens because of the electric field, and the participants are minority carriers of the junctions, minority carriers of the P and N junctions. Is this absolutely clear? Everybody with me? Give me a thumbs up if this is understood. Cool. Okay. Clear till this point? Everybody? Okay. When this junction P and N wafers, they are not connected to anything, this drift current will be equal to the diffusion current. They will balance each other. They will balance each other. But when it is forward bias, then diffusion current is more than the drift current. And when it is reverse bias, the drift current is more than the diffusion current. That is what it is. Clear? Okay. Yeah. Yes. So you should know all those things, guys, like the characteristics of current versus voltage and all of that. So this particular thing, this is where the current is, this is where the voltage is, and the graph is like this in case of forward bias. So this is forward bias, and here this is because the diffusion current is more than the drift current, and the total current is the diffusion current minus the drift current. Whereas in the exact opposite manner, the current is very, very less. This is sometimes also called as the leakage current, and this is the drift current. This drift current will be first minus the diffusion current. This is what happens in the reverse bias. You will also see the depletion zone. The depletion zone increases in size. Yes, the depletion zone increases in size. That is what happens. Okay, this is a very, very important diagram. Also, the breakthrough occurs somewhere over here where suddenly the voltage begins to increase. This happens at a point called as the knee voltage, when your barrier is broken, when the potential barrier is overcome. When you overcome that potential barrier, there is a wall of potential voltage difference. When you apply forward bias, the voltage barrier decreases, and you overcome it, then there is a sudden surge of current. Yes, a very good surge of current that is going to happen after the knee voltage. You should know all these terms. You should know all these particular terms. Okay, in case they ask you forward bias, reverse bias, etc. Is this absolutely clear, everyone? Yeah. S- Uh, no, that breakdown voltage occurs over here. Don't get confused. Breakdown happens over here. This is called as your breakdown. Breakdown voltage, also sometimes called as avalanche. Avalanche means you might have seen snowy mountain. Suddenly, one big chunk of snow falls down. Zoop! Yeah, big avalanche, right? Glaciers melting, and then an avalanche is created on those snowy mountains. So this is like an avalanche, sudden drop. So that is why it is called avalanche breakdown in reverse bias, where if you keep on biasing it, apply reverse voltage beyond a point, sudden surge in current is there, sudden surge in current is there, and voltage no longer increases. And this is where you use your Zener diode. This is where you use your Zener diode, because the voltage does not change over here appreciably, whereas the currents can change. Is this absolutely clear? Yeah, very good. Some of you are also confused about, sir, that 0.5 that odd number and that not so odd number thing. See, guys, I'll tell you very clearly. Observe this. See, let me be very clear. Dark. For dark, what is it? Y is equal to odd times by 2 lambda d by small d, which is odd times by 2 into fringe width. So if you see what the numbers will be, odd numbers are 1, then 3, then 5, correct? Then 7, and so on and so forth. Is that right? So if you see what the numbers actually come out to be, it will be 0.5 times beta, then 3 by 2 is 1.5 times of beta, 5 by 2 is 2.5 times of beta, then 7 by 2 is 3.5 times of beta. These are the numbers of the y coordinates for a dark fringe. Is this absolutely clear? For a bright fringe, you might be wondering, sir, how can I take all the numbers? I thought it will be only even numbers. You are right in a way. See, if I take even numbers, then divide it by 2. But we do not do such things, because even number is always a multiple of 2. Even number is always multiple of 2. 2, 2 cancels. So instead of that, what we write is we just write n times of lambda d by d, which is also n times of beta, which is nothing but n times of beta. Is this clear? So what will be the values of the y coordinate? 1 beta, 2 beta, 3 beta, 4 beta, etc. None of these values will ever match with any of these values, because if that happens, that means bright and dark at the same place, which can never happen. How can it happen? So if it is bright, it is bright. If it is dark, it is dark. So between 1 and 2, you get a dark. Between two dark, 1.5 and 2.5, 1.5 and 2.5, you will get a bright. Between one bright and next bright, you will get another dark. So that's how that increment happens at every 0.5 beta. Every 0.5 beta, the increment or the change happens from bright to dark, dark to bright. Is this now clear, everybody? Yes. Everybody? You took unit as joule. I have multiplied the value of volts into electron 1.6. That is the reason. Yes, this Gokul. Okay. Yeah. So this is any integer. If you don't want to look at it that way, it is also even times by 2 lambda d by t. But then that 2 has to come. But I don't want to write that 2. Then, oops, sorry, I had to write d over here. By mistake, I wrote 2. Yeah. So if you don't want to write it like this, then just put any natural number. Then put just any natural number. Is that clear? Very good. Very good. Awesome. Awesome. Yes, Pikachu, derivations have reduced and numericals are increased. Is this clear? Yes, silicon, Zener diode. Yes, all diodes have similar nature. What's the difference between a normal diode and a Zener diode? It's a diode, but just that in a Zener diode, it is heavily doped. It is made sure that it works at a certain regulated voltage. You design that Zener diode to operate at a particular breakdown voltage. That's the only difference. The graph will be the same. You can choose. I want the voltage to be regulated at 7 volts. I want the voltage to be regulated at 5 volts. So accordingly, you will make sure that the doping and the elements are such that the breakdown happens at 7 or 5. And because you are operating in the breakdown region, so you need to have it heavily doped, and yes, the sizes are slightly bigger. That's it. Otherwise, there is no difference in the graph. Is that okay? Right. Okay, cool. So now everybody clear about all these things? Shall we move to the next section? Give me a thumbs up, guys. Shall we move to the next section? I'm answering, taking care of all your doubts also, and I'm also going beyond the question because I feel some of these things might even come in the examination. And I don't want you to say, sir, I did not study that. Yeah, PDF will be provided after the class. Don't worry. Section C. Shall we go ahead? Have you smashed the like button? Have you understood? Shall we go ahead, guys? Drift is neglected, right? In the reverse due to minority? No. In the reverse bias, drift is bigger. Drift is bigger. Where is it? Drift is bigger. Where did it go? In the reverse bias, the drift is bigger than the diffusion. Okay, the drift is bigger than the diffusion. So drift is not neglected. In fact, drift is participating in that reverse voltage. In the forward bias, the diffusion is majority, drift is small. So usually you tend to ignore the drift current. Usually you tend to ignore the drift current because this current is so huge. Majority of it is because of this. It's not because of this. Is that okay? All right, all right. Rectification, I will, okay, probably put a content on that for tomorrow. Okay, in tomorrow's mock test, I will do that. All right, don't worry. Great. What is the characteristic property of the force which explains the constancy of the binding energy per nucleon in the range of mass number A lying between 30 and 170? Interesting. So this is binding energy per nucleon, and this is your atomic mass number, and the graph of that basically goes like this, and you can see that there is a certain range from here to here, from 30 to 170, where the binding energy per nucleon is roughly constant. Yes, where it is not changing much, it is almost a constant before it again starts reducing. The reason for that is very straightforward. See, what happens is when you have protons, they will repel each other. So to keep them together, you need pacifiers, which are neutrons. They are the neutral particles. Yes, they are the neutral particles which make a bond between those protons by nuclear forces, and that's how they keep them in intact. It's like two friends fight with each other. So you need a third person. Uh, so this guy made a friend, this guy made a friend, and these two are friends. So now they are all together. They hate each other, but they are together because they are with friends. They are friends with, you know, people who themselves are friends with each other. So something like that is what you can think. So that force which keeps them together is the nuclear force. Now imagine you add more protons. And because you add more protons, what will happen, guys? You will get more repulsive forces. So you will need more friends who are friends with each other. You will need more friends who are basically friends with each other, so that now they can all start staying in intact. But there is a problem with this. Now just imagine a big nucleus. Imagine a big nucleus like whose atomic size, an atomic number is 40, 50, 70, 80, like that, or even 120, 170, like that. So in that ranges, what happens? Even if you add protons over here, this friend can probably make a friend beside himself, and that can keep that proton together. But this guy can't make friendship with this guy. That means the nuclear forces can't reach all the nooks and corners of the nucleus. The influence of the nuclear force is limited. The influence of the nuclear force is limited. So if you take this particular if you take this particular neutron, the influence might be limited only in this particular region. It can't affect the other protons and neutrons. So when you add more of them, it does not increase the stability, and if it does not change the stability, it can't keep more protons and neutrons together, then it will hardly change the binding energy per atomic mass number, because this particular number which is there, binding energy per atomic mass number, corresponds to the stability of the nucleus. So the of influence sphere of influence of nuclear forces is definitely limited. It's limited. So that's the reason why adding more neutrons will not change the stability. Is this clear? So more number of neutrons won't affect the stability, Therefore, binding energy per atomic mass number is roughly constant in this particular region. It is definitely constant in this particular region. Okay. Now you should show this graph. If you can show this thing, that hey, this neutron, this is the influence in which it can affect other protons and neutrons, and these neutrons are not affected, they will love those explanations. Even they are not in NCERT, they love diagrams. Please keep that in mind. Okay, the sphere of influence of the nuclear force is limited for a small range. You can write all these points. Therefore, the more number of neutrons won't affect the stability. Therefore, the binding energy per nucleon will be constant, because that is what relates to the stability. But beyond 170, what happens is that when you keep adding more protons, more neutrons, neutrons are not doing any benefit. Neutrons are not of any use beyond a certain limit. But the protons, they will start hating each other. There will be too much of hatred between the protons, and that hatred, basically the electric repulsion, will overcome the nuclear forces which are binding them together. That is when the electric repulsion will try to rip apart the nucleus, and that is when it becomes unstable, and that is why the instability causes the binding energy per nucleon to drop. That is why the binding energy per nucleon will drop. Is this now clear? Everyone? Everybody with me? Everybody with me? Give me a thumbs up. Yes. Great, great, great. Awesomeness, awesomeness. So you should write all these points. Yes, you should write all these points, of course. Now, so that the density of the nucleus over a wide range is constant, there is a simple formula for that. Density of the nucleus is mass of the nucleus upon volume of the nucleus. Mass of the nucleus is mass of either proton or neutron. So I can write it as m multiplied by the number of nucleons. Volume is 4 by 3 pi into radius cube. Nucleons means protons and neutrons. This is mass of proton, which is roughly the same as the mass of the neutron. So any one mass multiplied by the nuclear particles, which is either the proton or the neutron. Just like if I stay in Bangalore, then I'm called a Bangalorean, right? So same way, if I stay in India, I'm called an Indian. Same way, if somebody resides in the nucleus, they are called nucleons. So what happens now is this m which is mass of a proton, let's say, multiplied by number of nucleons is basically atomic mass number, 4 by 3 pi. Radius formula is R naught a raised to 1 by 3. That's the standard formula, whole cube. So this 3 will go on the top, mass of the proton divided by 4 pi. And then you have A over here, you have R naught, which is a constant cube, and then you have A over here. What happens is, the best part, A and A gets cancelled. All these numbers are constant. So therefore, it is also a constant. Therefore, it is also constant. So the density is constant, hence proved. The density of the nucleus is independent of A. You can see it is right over here. It is getting cancelled. So it is definitely independent. It is definitely independent of the atomic mass number. Atomic mass number, which is the total number of protons and the neutrons. Is this absolutely clear? Everybody with me? Very good, guys. Awesome. Keep it going. Keep it going. I want everybody to keep loving the session, keep solving the questions, keep answering it. Yes. Yes, it is of very high value. Correct. Okay. Now going to the next question. The absolute refractive index. Air is this much. Wavelength of light is this much. See, air is not perfectly one. The decimal place, after like 3-4 decimal places, you get a number. It's nearly one. What is the thickness of the air column which will contain exactly one more wavelength of that light in that same thickness as in vacuum? Very good question. Read it again to understand it. See, even CBSE can ask such kind of questions, means it is very interesting. Let's understand this particular question, guys. Let's understand this particular question. Let me create a duplicate. Okay. So we take a column. We take a column of what do you say? Column of air. So let's say we take a column of air, and then on the side of it we take an equal column of vacuum. This is of vacuum, and the air should contain one extra wavelength. That's all. See, wavelength depends on the wave speed. V is f lambda. Speed reduces, wavelength will reduce. So vacuum, the wavelength is more. So probably, let's say 1, 2, 3, 4, 5, 6. Some 6 wavelengths are here. Here, what will happen? 7 wavelengths should come because the wavelength is smaller. So maybe something like I'm doing 1, 2, 3, 4, 5, 6, 7. So extra 1 wavelength is there. So here, if there are n number of wavelengths in vacuum, which I call it lambda 1, then here we should have n plus 1 wavelength in air, let's say lambda 2. That's all. That is the thing which should happen. That is the thing which should happen. Everybody with me on this? Everybody with me on this? Very good. Very good. So what will be the equations which I will write? Okay, what will be the equations which I will write? Observe carefully. Let's assume that particular thickness to be T, and that is what we have to find, right? We have to find that thickness. If I write it for vacuum, that particular thickness will be n times of lambda 1. Therefore, n will be T by lambda 1, right? So what is that wavelength? What is that wavelength? We already know. Yep. So that is nothing but 6,000 Armstrong. So T by 6,000. Everything is in Armstrong, assuming that. So that is your N. Similarly, for that air who has some refractive index. Refractive index of air is 1.0003. So the wavelength in air will be wavelength in vacuum divided by the refractive index. That means it will be 6000 divided by 1.003. That is the standard formula. So now I will then say that the thickness T will be n plus 1 number of such wavelengths are there. So therefore, n plus 1 will be thickness by lambda 2. So it will be thickness by that lambda 2 is nothing but 6000 and 1.003 will be over here, and this would be n plus 1. Is this absolutely clear, my dear students? Is this absolutely clear, my dear students? Yep. Very good. Now, what is the next step, sir? N can be substituted from here. Just take this N and substitute it here. So, see what you will get. We'll do it on the next slide. T by 6000. So, this will be T divided by 6000. Okay. Plus 1 plus 1 is equal to T into 1.003. T multiplied by 1.00 0.03 whole thing divided by 6000. Is that right, everybody? So I think we can take this guy over there. So 1 will be equal to T divided by 6000, and it will be 1.0003 minus 1, I believe. 6000 can be taken on the top. 6000 can be taken on the top, and this will be 0.0003. So therefore, thickness will be 6000 divided by 0.0003. Is that right? That is what the thickness will come out to be. How much is the answer? How much is the answer? Yep. Come on, my dear students. You will get 2 into something. Everything is in Armstrong. Remember, I never changed the units. I have kept it in Armstrong. Yeah, it will be in Armstrong. How much will it be? 10 to the power 3, 1, 2, 3, 4. So goes on the top. So it will be 10 to the power 7. 2 into 10 to the power 7 Armstrongs. Everything is in Armstrong. Yep, everything in Armstrongs. So, but an Armstrong is nothing but 10 to the power negative 10, which is meters, of course. This is meters, of course. So this will be 2 into 10 to the power minus 3 meters, which is obviously 2 millimeters. 2 millimeters is the answer. What a lovely question, which will give you 3 marks. What a lovely higher order thinking question, which is going to give you 3 marks. Isn't that right? Yeah. Everybody, how many of you loved this question? Yep. Sir, is it possible to revise first volume today? See, my dear students, just please go to video section. I have created these beautiful classes for all of you. 10 hours, 4 hours, 8.5 hours, 5 hours, 5.5 hours. What is this for? All chapters I have revised for all of you. Please go through that. Please go through that. Modern physics, I would suggest you can directly check out my JEE classes also. They are good enough because the level is good only. And JEE classes are equivalent for you for your NEET syllabus also. Semiconductors also have taught beautifully from NCERT. It's there on the channel. Okay. So we are already on to section C, but see the questions, guys. Very good questions are there. How about this question coming up on your screen? There is a rod going from east to west, falling with some speed at 90 degrees with Earth's magnetic field. What is the value of the field, sorry, EMF, the direction of the EMF, and the which end is at higher voltage? Okay, moving on to the next question, my dear students. Let's see if you guys can figure this out. All right, more half an hour, 20 minutes, not more than that. Okay, first of all, I will show that rod, and that rod is in the east-west direction. Rod is in the, this is the east side, this is the west side, and it is falling down. It is falling down. So it is falling downwards. Yes, it is falling down. Okay, the velocity is also given to you. Okay, some value. Remember, if east is here, west is here, front is north, behind is south. So please keep that in mind. Okay, so going like this is north, going like this is north, and coming this way, this is basically south. It is not up and down. That's a common mistake. If I look in the front, this is east, that will be north. Behind of me, this way will be south direction. And we know the magnetic field, the magnetic field of the earth will be like this in the north-south direction. That's all. That is enough for me to solve the questions. Yes. How will the magnetic field be going on the earth? How will the magnetic field be going on the earth? Will it be going from north to south or from south to north? Quickly answer the question. Will it be going from north to south or south to north? Think about it logically. If this is your earth, come on, my dear students, the magnetic south pole is here, north pole is here. Yes, it is exactly opposite. At the north, you have the south of the magnet. At the south, you have the north of the magnet. So here the magnetic field lines will go from down south towards the north. So magnetic field lines go from south to the north. Always remember that. They go towards the north because we know a magnetic needle points towards the north. So 100% the magnetic field is inside. Magnetic field of the earth is inwards. Is that right, everybody? Yes, south to north. Now comes the quick question. EMF induced. The EMF, motional EMF, is magnetic field length into V. So magnetic field is 0.3, 10 to the power minus 4, length 10 meters, velocity 5, velocity 5. 3 5s are 15, 10 and point cancels. So 15 is there into 10 to the power minus 4 volts, which is 1.5 into 10 to the power minus 3 volts, which is 1.5 millivolt. So the induced EMF is done, which is 1.5 millivolt. Everybody got it? Very good, the Gokul. Awesome. Yeah, Srivas, you can definitely watch my previous one shots also. No issues. Now, how to decide who is higher, who is lower, all those things. See, I'll tell you one simple trick. Sorry, this was 5, no? One simple trick. Yes, Fleming's left-hand rule and all those things are there in the syllabus. You can use that. But the best way is to find the direction of EMF. The EMF is always going to be parallel to, okay, is always going to be parallel to the velocity cross the magnetic field. Velocity cross the magnetic field. Velocity is down, magnetic field is inside. Velocity is down, magnetic field is inside. So take the fingers of your right hand, 4 fingers, point it in the direction of velocity, which is downwards. Slowly bend it towards the magnetic field. You will see the thumb going this way, the thumb going that way. So 100%, yes, just try it out, guys. The 4 fingers of your right hand, just try it out. You will see that the thumb will point in the direction of the EMF. So the EMF is in this direction. Yes, just try it out. Right hand only. Yes, right hand only. So which means this is negative, this is positive. The current will go like this. The current will go like this. So this is at lower potential. This is at higher potential. That's it. So what is the direction of the EMF? From west to east. From west side to the east side. Which end of the wire is at a higher potential? Obviously, the eastern side is at a higher potential. The eastern side is at a higher potential. Is this absolutely clear? Many students make a mistake over here. Okay. So, yes, east to west is wrong. It is west to east. Be careful. Again, see guys, velocity was down. It is clearly given. It is falling down. Down means here. East is here, west is here, north, and the magnetic field is also here into the plane. Behind me is south. So velocity, take the right hand like this. If you want, face the screen. Already you are facing the screen. Take your right hand, tilt your hand like this in the direction of velocity. Slowly move it towards the magnetic field. Magnetic field is inside. Magnetic field is inside. V cross B. V cross B. See, your thumb is going towards the right side. So the current or the EMF is towards the eastern side from west to east. So west to east. And when the current goes like this, battery supplies the current. So battery always supplies the current. The EMF is this way. So this is at higher voltage. This is at lower voltage. Got it now? Everyone? Direction of induced EMF same as the direction of current? Yes, Prajesh. Yes, always. Magnetic field direction, always remember this as a rule that it will be always coming. Okay, see, I'll tell you, simple thing. See, this is Antarctica. India is on the northern hemisphere. This is southern hemisphere. This is Arctic region, Russia, Canada. This is North Pole. If you take a bar magnet or a magnetic needle, the needle will point towards the north. Where will it point? It will point towards the north. Why? Because the magnetic field lines are going towards the north. They are going towards the north. So magnetic field goes from south to the north. That's why I showed the magnetic field of the earth going from south to the north, basically towards the North Pole, Earth's North Pole. Okay, where the magnetic South Pole is there. Is it now clear? How V is down? It is given. It is falling. It is falling. It is already mentioned. Is that okay, Sanjay? Yeah, everyone? Magnetic field will not be in the opposite direction because for Earth, it has to be in the north side. It will be always in the north side, 100%. If it was for some other planet or some situation, it is towards the south side, then V cross B will be exactly opposite. So this direction will be opposite. So battery, I will show it like this then. I will show it like this. That's the only difference. It will be exactly opposite of that. No, 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 no. This is correct only. Sashwin, electrons move from west to east. No, no. It's the electrons which move from east to west. So that's why the current will move from west to east. Okay. So do not forget, Sashwin, if there are electrons, what will happen? V cross B will be towards the right. V cross B will be towards the right. But since it's a negative charge, the electrons will experience a force towards the west. So technically speaking, the electrons will migrate over here and this side will become positively charged. So you can see this is at a higher voltage and this will be at a lower voltage. Even by Lorentz force also you get the same answer. If you take electrons, the negative charge will force them towards this side. Q V cross B. V cross B will be this way only, but with a negative sign, the force will be towards the left side. Is this absolutely clear? Yes. For every such question, Yugant, magnetic field is in the north direction. I'm not saying it is inside. Magnetic field is always in the north direction because of the earth. The horizontal value of the earth's field. The horizontal value of the earth's magnetic field. Is that okay? Cool. Understood. Such difficult questions can also come. Is that okay, Yugant? It's not necessarily inside, you understand? Because this is your perspective. See, if I draw it from top view, then I will say this is north, this is east, this is west, this is south. Then I will say the Earth's magnetic field is this way. The magnetic field of the Earth is this way. But this is obviously now the top view. This is now the top view. If you look at the side view, then I will say, okay, the north region is inside, the south is towards me, east is here, the west is here. In that case, I will say the magnetic field is going inside like this. Magnetic field of the earth is going like this. Now this is, this kind of view, the side view, where this is down direction and this is basically your up direction. I'm just standing on the earth. and looking east, west, no, up, down, north, south. If I'm looking at it from the top, how will it look? North here, south here, down here, up here, like that. So this will be then upwards and this will be then downwards. It's just a perspective. Awesome. Awesome. Thank you, Charanjit. Great. Got this question in my school. Yeah. CYQ is current year question. I think somebody attack already explained it. Okay, cool. Great, great, great. Next question. A metallic rod, length L, resistance is rotated with some frequency, hinged at the center, other at the circumference, passing through the center, constant field is there. Derive an expression for EMF. Find the current in the rod because of which the force will be there. Sorry, due to the current, there will be a force in the rod. Find that force. Hence, obtain the power to rotate the rod. Okay, so I'll tell you what the question is all about. You basically have taken a rod like this of certain length. It is hinged over here and it is rotated with certain frequency, let's say omega, angular frequency. The length of the rod totally is L. That's the total length of the rod. And there is magnetic field everywhere. There is magnetic field everywhere in this particular region, that is B. And then you have ensured that the other end of the rod touches a circular arc, basically a ring-like structure. So there is a potential difference across both the ends, the center and the circumference. Question is, what's the potential difference? The logic for that is, you take a small element over here whose length is dx at a distance x, which is moving with a velocity v. So there is a small motional EMF, which is d in that element, dx. That will be b, length of that element, into its velocity. But wait a minute, I know what the velocity will be. It will be omega into r, radius is x. Yes. How did we go from here to here? Velocity tangential is angular speed, which is omega, multiplied by the radius. That's what I'm using. Omega into r. Now, if this is dE, I can then say the total EMF in the rod is the sum of all the small EMFs. So there are many elements like this. They are all in series. You add them off, you will get the total EMF. That means integral d. That means integration of b dx omega x. You can take b omega outside and x and dx will be inside. Limits will be 0 to L, starting from x equals to 0 to L. So that will be b omega. X's integration is x square by 2. X square by 2. Limits are 0 to L. So when you substitute it, you will get b omega L square by 2. But that is not the answer. That is not the answer. You have to write it in terms of frequency. And we know frequency is 2 pi f. 2 pi nu is the frequency, and this is L square, and this 2 will come. Therefore, the EMF will be B pi V nu, actually nu L square, B pi nu L square. That is the answer. B pi nu L square. Omega is 2 pi f. Is that right, everyone? Is that right, everyone? Till this point, everybody clear? Awesome. Yes, sir, it is clear. Great. The 2 got cancelled. Yes, the 2 got cancelled. Now comes the next step. Okay, sir. Till now, I got that EMF. Fair enough. Let me just remove this. I don't even need this now. Okay. Anyways, I have kept it on the previous slide. If this is the EMF, I can now start finding how much current will be there and how much force will be there. We know current will be EMF by resistance. So it will be B pi nu L square by the resistance of that rod. This stands for resistance, not radius. So this is the resistance of that rod. I can find the current. From current, I can find ILB force. So force, remember, the force is I into L into B. So current is B pi nu L square by R. Length is L into B. So that force will be pi nu L square into L will be L cube and B square, the whole thing divided by resistance. So that is the force. That is the force which will be experienced by the rod, and you will have to compensate it by applying external force. Only when you apply this much amount of force, it will rotate, because this force is applied by magnetic field. To balance it, you need any other external force. Yes. Is this absolutely clear? So this is the force by the magnetic field on the current carrying wire, which is same as the external force needed to keep rotating it. Keep rotating it. So you have to balance it with exactly the same force. If the forces are balanced, the body continues the state of motion. Remember Newton's first law. Yes, when the forces are balanced, the body continues to rotate or do whatever it was doing. Now comes the last part, which I believe is this. For the power required to rotate the rod, find out the power required to rotate the rod. So what is the power, my dear warriors? What is the power now? Yep. What is the power? Force into velocity. Force into velocity. Yes, correct. But there is a problem. Yeah. This force and this velocity. Sorry, we know the force and we just need to multiply by velocity. Okay, that's it. So what we can also do, instead of writing force into velocity, the problem with writing that velocity is every point will have different velocities and the forces will be also then distributed. I will again have to use integration. So the power needed, I can just write it as the power which is lost, which is current square into resistance. So just substitute the value of the current which I have got over here, which is nothing but B pi frequency L square divided by R square of the resistance, so current, into resistance. So that will be B square pi square nu square L raised to 4 R square and R, 1 R will remain. So that is the power. Current square into resistance. So that is what the power is going to be. Is this absolutely clear? Yes. Don't use force into velocity, because I just realized which velocity will you take, because every point has different velocity. Closer points have small velocity, far away points have more velocity. So which point will you take, right? That is the problem. That is the problem. Got it? So whatever power is given will be also lost in that heat across that rod, across the resistance. So that is the formula that we use. Okay, great. Next question, guys, coming up on your screen. YDSE, the slits are given 1 meter apart, 10 fringes is this much. Calculate the wavelength used. If now the width is changed, what will be the distance between, what will be the width of the 10 fringes? Okay, this is simple question. I will not solve it completely. I'll just give you the hint. See, here it is given 10 fringes, that means 10 beta is already 3.93 millimeters. Therefore, beta is 3.93 by 10 millimeters. So that will be 3.93 10 to the power minus 3 by 10, which is 3.93 10 to the power minus 4 meters. Now, from this, you can use the formula lambda d by small d is equal to 3.93 10 to the power minus 3. This distance is already given 1 meter, and this is given 1.5 10 to the power negative 3 meters. So from this you will get the wavelength. That is the first part. Calculate the wavelength of the light used. So that wavelength you will get. Once you get that, it is given the distance between the slits and the screen is increased by 0.5 meters. That means the new distance is 1 plus 0.5, which is 1.5 meters. So you can find the new fringe width given by lambda d by small d. So lambda, whatever you got from here, distance is 1.5. Small d is still the same, which is 1.5 10 to the power minus 3. Okay. From this you will get beta. But the question is, what is the width of 10 fringes? So then you just multiply the answer with 10 beta. So it will be 10 multiplied by whatever answer you got here. So that will be your final answer. That will be your final answer. I have given you the complete step-by-step procedure. I think you will be able to do it. Yes. Yes. I hope this is absolutely clear. Yes. Absolutely clear. Very good. Very good. Great. Shall we go ahead to the next question? Okay. Can you figure out this? Describe how to use each of these diodes. How are these diodes used? I want everybody to spam the answer in the chat box. Yes, everybody spam the answer in the chat box. Oh, we had many people give us um, super chat. I'm so sorry, I missed out few names. I think I could just see that time only one. Some people had given super chats. We should definitely applaud them. I hope I can see those few. Meanwhile, just answer that particular question. Oh, thank you so much. Thank you so much, guys. Meme execute 20 rupees. Thank you, yaar. Thank you so much for the super chat. Shreyas sir fan. Thank you. Can we get 90 above after seeing this session? Why not? Why not? I feel you should get 100 out of 100. You should get 100 out of 100. Not just today's session, even tomorrow's sessions. Please watch it. Thank you, Capto. Means a lot. Means a lot for raising those funds. Thank you, Ramchandran. Means a lot to me too when you put up such amazing messages. And let's do it, guys. CBC 2025 480 plus. Wow, so cool, so motivating. Very good, Ramchandran, and a lot of people commenting too. Yeah, Veera level macha. Awesome. Thank you so much uh, for the shout out, guys. Thank you so much. Yeah. Great, 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 great. Okay, cool. Love you too, Abhijit. Thank you so much. Okay. So how do you do this? Photodiode. Photodiode is in forward bias. Zener diode, oh sorry, photodiode is in reverse bias. Reverse bias. Zener diode also in reverse bias. LED is in forward bias. Solar cell, it is not biased at all. It is a cell in itself. You don't need another cell for it. Yeah. Okay, cool. Very straightforward. Moving on. Maybe also useful for your JEE NEET purposes. Oh, sorry. Deleted. So sorry. Yeah. Okay. Ignore then. Ignore. My bad. Okay. No issues. Then next question. Oops, what is this? Radioactive nuclei decays into this and this. The maximum energy emitted by the positron is this much. Given the mass of carbon, boron, and I think even the positron should be also given. What is the energy of the positron emitted? Q value. So what is that Q value? Yes, you should know this. What is this particular Q value? So this particular Q value is nothing but the mass defect that you get multiplied by the c square. But if you write the mass defect delta m in atomic mass unit, then you just have to multiply this with the number 931 so that you get the answer in mega electron volt. So that you get the answer in mega electron volt, and everything is atomic mass unit. So that is beneficial to us. As you can see, this side and this side, the masses are given already. So it will be nothing but 11.011434 minus, there is one boron whose mass is 11.009305. Okay, and that positron's mass also should have been given. I think it was mentioned here, 0.000548. This should have been given actually. Mass of that positron, 0.00548 atomic mass unit. This should have been given, guys. It was not mentioned in the question, but I have added it back. So minus 0.123548 atomic mass unit multiplied by 931. That final answer will be in mega electron volt. 1.47 mega electron volt. Okay, we are getting 1.47 mega electron volt. Just check this out. Just check this out. So the answer given in the solution is definitely wrong. Yes. Are we getting 1.47 mega electron volt? Just check this out. Now, out of this, if it is compared with the positron's energy, the energy emitted of the positron, so 0.96 mega electron volt is with that positron, which is definitely less than that 1.47, which is perfectly okay. That means where is the remaining going? Where is the remaining going? The remaining energy, the remaining is with whom, guys? Is with probably the other particles, like boron, etc. So the other particles have that remaining energy. That is what it would mean. Okay, just check. Yes, the solution given was 100% wrong because there is only one positron given. So one boron given, one carbon given. Okay, with these values, you get this as the answer. So the energy released is 1.47, but positron gets 0.96. So the difference is going with the other particles, and it is perfectly okay that the positron comes out with little bit less energy than what has been emitted, because other particles will also take away that energy. Is that fine? Yeah. Binding energy is there. Don't get confused, or don't confuse this with the radioactivity. Radioactivity is completely different. That is, dN by dt is lambda and decay constant half-life. That is not there. Don't confuse. Okay. So this is your passage or case study based question. Just take a screenshot of it. Okay, I can't keep coming back. Just take a screenshot. I will move away from the screen. Just try to answer these questions which are going to follow now. Yes. What if today's questions come in the exam? Then it is lottery only, no, Charanjit? And it is good only. Why are you sad? Okay, great. Have you taken this screenshot? See, visiting Tamil, all I have done is Q value is mass defect into C square in joules, but in electron volt, it is mass defect in atomic mass unit into 931. Delta M into 931, that's the formula. So mass defect is take the masses on this side, take the masses on this side and subtract the two. So if you see this guy's mass, it is this much. If you see these two people's mass, it is this much and this much. So I have subtracted them and then multiplied by 931, I get this answer. That's all I have done. Okay. Now this answer is basically the energy which will be released in this process. Now where will this energy be with? It will be with all these particles, meaning the kinetic energy. So if the positron has this much energy, so that means the remaining energy is with other particles. That's all. Mass defect is basically take the bigger mass, expected mass minus the actual mass. So is the difference of the masses. Take the bigger mass minus the smaller mass. This is the mass of, this is that particular mass of, you can see on the left hand side, and this together is the mass on the right hand side. Is that right? This together is the mass of the right hand side of boron and that positron, and this is of that carbon. Is this absolutely clear? Everything was given in atomic mass unit. One atomic mass unit is 1.67 10 to the power minus 12 kg. Remember that formula? Is that okay? Now clear? Okay, cool. Let's go to the passage. This is a passage. Read this. Questions are based on that. Which of the following electric field is zero? What is the sign of the charges? And which of the two charges is greater in magnitude? This is one set of question. Okay. So more questions are there, I think. More questions are there. Then which of the following is not true, means which of the following is false. And lastly, positive negative charges of equal magnitude are kept. What is the work done by the field when you go from this point to this point? I think these are the, yes, all the questions which are given. So let's start with this. Which points the field is zero? What is the sign? And who is more in magnitude? Look at the graph. Where is the field zero? If you remember, there is a formula for electric field. Electric field is negative dV by dr. So if you want E to be zero, that means dV by dr should be zero. That means the slope of potential versus R is going to be zero. I think there is only one point. There is only one point in this entire graph where the slope is zero. Can you see that point? Yes, the slope is zero. Maxima point over here at 0.3. So I believe the answer should be 3. I believe the answer should be 3. How many of you got it? Yes, derivative 0. That means the slope is 0. Everyone till this point clear? Okay. Next is, what is the sign of the charges? When you are near Q1, can you see that the voltages are definitely positive? When you are near Q2, can you see the voltages are definitely on the negative side? So Q2 must be negatively charged and Q1 must definitely positively charged. Is that right, my dear warriors? Because negative potentials at negative charges, positive potentials at positive charges. So positive and negative, is that right? Positive and negative, which is option A. Option A, everyone? Yes. What about 1, point 1? Point 1, okay, point 1, point 1. Is point 1 mentioned in the thing? Okay. Point 1 could be, see, the problem with point 1 is that, I'll tell you why it is not point 1 for sure. The graph is just, see, how is it coming? It is coming like this and it is going like that. If you draw a tangent over there, if you draw a tangent over there, the slope is definitely not 0. This is your point labeled 1. Is that clear? So if you draw the tangent over here, maybe it is not going to be 0. You cannot be for sure, but for sure at 3, it will be the answer. Is that clear? Sumati, do you know this formula? Electric field is dV by dr, negative sign, rate of change of voltage. So if the field is 0, that means the derivative is 0. Derivative is 0. Derivative means slope of voltage versus distance. This is voltage, this is distance. So where is the slope 0? The tangent drawn should be horizontal. That's it. That is where the slope is 0. There is only one point, and that is point number 3. Got it now? Everyone? Absolutely clear? Pakka? 100%, sir? Okay. Shall we go to the next part, which says which of the two charges is more in magnitude? Which of the two charges is higher in magnitude? Okay. Now again go back a little bit and then you will start seeing. See, this negative charge has a negative influence around it, but when you go far away, Do you see again the potential is becoming positive? That means this guy's effect is going away, fading away, and the potential is becoming positive. Why would it be? Because this guy's effect has gone away, and this guy is very, very, very large, because of which still it has some effect over here. So when you go far away, you can see charge 1 dominates charge 2. When you go close, charge 2 has more profound effect. So that means charge number 1 would have been more than charge number 2. Got it now? Everyone? Is this absolutely clear? Think about it. Okay. In the local region, Q2 dominates, which is okay. You are very close to this. But when you go far away, that's where the real test is. Who is higher? When you're close to a person, that person might love you. But when you're far away, that's where the real test is, whether you are able to maintain that relationship. So this guy still being positive, that means this guy being so far is able to dominate this charge which was so close. So Q1 will be higher. So I think the answer for this one should be Q1. Let's check it out. Yes, Q1 positive and 3. Perfect. Yugant, now clear? Yeah. Is this absolutely, absolutely clear? Everybody give me a thumbs up. Saran, passing is very easy. Just solve model papers, PYQs, watch my recorded classes, and attend these sessions. Not only will you pass, you will get at least decent score. At least decent score. If you are so horrible in your studies, then because you are asking that question, I'm assuming that you have not studied at all. So that case, please watch the recorded classes which I have just put up on the channel, all one shots detailed classes. Watch it in 2x if you want. Okay, and then go ahead. Okay. There is no tukka strategy which you can apply. Sir, can you explain question 2? Yes, thumbs up. Thank you, Yugant. Okay. See the signs, no, just look at the value. See, whatever is there on the top, this is positive voltage. No, whatever is there on the top is positive voltage. Whatever is there below, these are the negative values of the voltage. This is your horizontal line. So, if near charge 1, the voltage is positive, that means what? The charge is positive. If near charge 2, voltage values are negative, that means charge is negative. Remember the formula for voltage. Remember the formula for voltage. What is it? Voltage is KQ by R when you are very close to it. So think about it. If the charge is positive, voltage is also positive. Think about it again. If the charge is negative, then the voltage is also negative. That is the reason why I said the voltage is positive, charge positive. Voltage is negative, charge negative. That's all. Is this now clear? KQ by R formula. Okay, great. Moving on to the next questions. Which of the following is not true? Which of the following is not true? Not true means false. Not true is the same as saying false. Which of the statements is false? Electric force is conservative. This is 100% correct. Is that right? Electric force is conservative. Super. Okay. Very good. I hope you guys are loving the explanations. Potential energy is a work done per unit charge in bringing a charge from any point to infinity. Is that right? No, I think it is exactly opposite. Yeah. It's infinity to any point. So this is wrong. This is wrong. When two like large charges lie infinite distance, their potential energy is 0. This is 100% true. So when R tends to infinity, potential energy becomes 0. Both A and C, no. Both A and C, no, definitely not. They are not false. So it is B option. Yes, very good. Option B. See, minor problem was there. From infinity to any point should have been there. Okay. Next, positive negative charges are kept at distance 0, 0, a by 2, 0, 0, minus a by 2. Work done by the electric field when another positive charge is moved from minus a to plus a. Okay, okay, okay. So this is very visualization based question. Okay. This is how it is. 0, 0, a by 2 that means z-axis, you have placed positive and negative charges. So one positive charge, this is negative charge on the z-axis, guys. They are separated like this. Please remember, this is your x-axis, this is y-axis, this is z-axis. Consider the 2 points minus a 0 0, minus a 0 0, that is this point, and 0 a 0 and 0 a 0. Oh, guys, this point and this point, are you able to see point 1 and point 2 will have the same potential? They will have the same potential. Why? Because they are at the same distance from that dipole. Same distance, same distance from the dipole. In fact, they are in the equatorial plane. Can you see that? Equatorial plane, which is your y-x plane or xy plane, which is your xy plane. Can you see? That is the equator. If two charges are there, you slit them apart equally. That is the equator. Yes. So potentials are equal. So the voltage difference between point 1 and 2 will be 0. So work done, therefore work done from 1 to 2 will also be 0. So I think it should be C option, which is correct. Yes, it is 0. Is this absolutely clear? Very good. Yep. Yes. Awesome. 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 Yep. Moving on. Moving on. Moving on. Yes, the solutions were given. Now, this question, guys, just take a screenshot of this second case study. Just take a screenshot of this second case study. I want everybody to think about this. Jimmy, Johnny, both were creating circular waves while fishing in the water. Jimmy, Johnny. Yes, you can see Jimmy, Johnny. Over here, they are creating circular waves. The manner in which they have drawn the diagram, it feels like, my God, they are peeing in that water. No, no. Guys, they are not peeing in the water. They are throwing something. They are thrown some stone. Okay. They are not peeing in the water. Okay. Their friend Anita advised Jimmy and Johnny not to play with the water for a long time. Oh my God. This is very weird, guys. Please don't think it otherwise. She then observed beautiful patterns of ripples which became a very colorful when her friend Lata also poured an oil drop on it. Lata, 12th standard girl, had explained the cause of colorful ripple patterns to Anita earlier. Okay, come on. Yeah, think about it. Bar magnet equivalent solenoid I have already explained in that NCERT session. Please check that out. If you want, you can see it right over here. Okay, just go to videos, and here you will find it. Bar magnet as solenoid and all of that I've explained. Yes. Yeah. And Power Manita caught them peeing in the pool. Oops. Anyways, they were disturbing the pool. They were making patterns. Please don't do such things, guys. Okay. So the questions are as follows. Name the phenomena. A surface over which the optical wave has constant phase is called. Which of the following is correct for light diverging from a point source? Come on. Answer these questions. Everyone. Hmm. Shailesh, Nan Tamil Terila. Yeah. Okay, first answer, guys. First answer. Which phenomena is involved? Obviously, the wave patterns are meeting each other. They are interfering. It is not reflection, refraction, polarization. What nonsense. Yeah, it is interference of waves. Surface over which an optical wave has a constant phase. All those points which have the same phase is called as a wavefront. Huygens principle, if you remember. Yes, B. Correct. Which of the following is correct for light diverging from a point source? Yes, light diverging from a point source. The intensity reduces. Wavefront is parabolic. Intensity does not depend. It definitely depends. As you go, you can see the light will become less intense. It is in fact inversely proportional to the square of the distance. So it is option A. Yes, square of square of the distance. Correct. This alone is not enough. Guys, why do you ask such questions? I feel very sad, when you guys ask such questions. Because tell me one thing, how can one session be enough? I mean, it's a joke, no? Then why should we prepare you guys for 1 year, 2 years. If any teacher is telling you, see, I'm not the teacher who will tell you just watch this session alone and you will get full marks. If that happens, no, either I have the paper or I am just making a fool out of you. And then I don't do either of the two. So, you should also understand if some teacher or if somebody is doing it, first of all, they are not teachers. They will do it for views, or they are just fooling you around. Leaked paper, or this will only come. How can you be so sure? No matter how much analysis you do, NTA fooled people this time. NTA gave very different pattern questions this time. Same thing board can also do. Board has also done that. Suddenly they made physics paper difficult in one of the last few years. So students came out crying. So you cannot tell bacha. You have to solve. You have to solve as many questions as possible. Yeah. Why not see? The intensity of a wavelength does not depend on the distance. It does depend on the distance. You can see it is dependent on the distance. So that's why C is not correct. I hope that is clear. Huygens concept of secondary wave is what? Allows us to find focal length geometrical method. It's a geometrical method to find the wavefront. Is that right? Yes. It's a geometrical method to find the wavefront. I hope this is clear. Very good, very good, very good, very good. Awesomeness. Last three questions. Numerical type, 4 marks each, 4 marks each. Come on. Prove an ideal capacitor in an AC circuit does not dissipate power. See, sometimes derivations can come. Yes, prove that an ideal capacitor in an AC circuit does not dissipate power. And there is some question on LCR or some Q factor and all of that. So I'll tell you what, for this particular question, if you have, let's say, this charge, this is capacitor, this is current, this is an AC source like this. This is the voltage, and the voltage is V naught, example sine omega t. Then the charge Q will be CV. That means it will be C into V naught into sine omega t. Now we all know current is the rate of change of current or charge. Current is the rate of change of charge. So C and V naught will come outside, and then you will have the derivative of sine omega t. So this will be C V naught into omega cos omega t. So that will be the current. So now comes the power. Power is voltage into current at any instant. So what will you do now? Yes, what will you do now? Yes, think about it. Power average you have to find. Yes, you have to prove the power average. So this is instantaneous power. So the average value of the power will be integral Vi dt from 0 to time period upon the time period. This is the average value. So when you do that, just substitute both of them. Integral 0 to t, the whole thing divided by t. Voltage is V naught sine omega t. Current is CV naught omega cos omega t. And then you have dt, of course. You can take a lot of things outside like C V naught square omega whole thing divided by t outside. You are just left with 0 to time period, which is also 2 pi by omega. You have sine and cos omega t over here. You just have sine omega t into cos omega t, and then you have dt over here. Deliberately, what I will do, I'll multiply by 2 and divide by 2 deliberately, because I can use a trigonometric identity then. CV naught square omega by 2t. This will be integration of 0 to 2 pi by omega. This will be sine 2 theta formula. So sine 2 omega t into dt. This integration for an average or a complete cycle will always be 0. We know this as a matter of fact, because if you take any sine function, for one period, obviously the positive area and the negative area will cancel. So this answer will always be 0. So this is definite integral. This definite integral will be 0. Hence, the answer is a big fat 0. So the average power is 0. Hence, proved. Prove that an ideal capacitor and AC circuit do not dissipate power. Hence, proved. Is this clear? This proof? Same thing you can also do for inductor. Same thing you can also do for inductor. Yes, very good. Question 3. What question 3? This one. This, no. Intensity, what happens is this. If this is a source of light, light will spread across this entire sphere, and that's why the intensity of light is inversely proportional to the square of a distance for a point source. So that's why intensity depends on the distance for a point source. So this is a standard result which you should know, as simple as that. There is no explanation as such I can give. I mean, there is a derivation like intensity is nothing but the power by the area, power by the area. Power is nothing but P, area is nothing but 4 pi r square. So you can see that the intensity is inversely proportional to r square. So that's how it is. This area is the area of that sphere. This is a sphere. So the complete area of the sphere is 4 pi r square. So that's the derivation part of it. Okay. Ha. This one, power formula is voltage into current, but you don't use VI cos phi. Don't use that. No, you have to prove it. So that is the reason why I have to go via this integral method. Yes. Okay. Hmm. Great, great. Awesome, awesome. Hello, Shreya. Welcome. I think you are quite late for the session, but it's okay. You can catch up to the remaining part in the recorded version once the live session is over. An inductor, capacitor, resistor, calculate the angular frequency for maximum power dissipation and calculate the Q factor. This is direct question. What's the formula for the maximum power dissipation? Means what? Resonance, isn't it? Resonance occurs at what omega? 1 by root LC. L is also given. L is also given. C is also given. Both are given. This job is done. Everyone, this was very straightforward. Okay. Very good. And then the next part, Q factor. This Q factor, what's the formula? 1 by R is there, and then you have root of, basically inductance by capacitance. Inductance is there, capacitance is there, resistance is there, substitute, you will get it. So that part, I will leave it up to you to solve. Okay, this is the answer that you get for omega and the Q factor. Okay, moving on to the next question. Compound microscope is there, focal length is there, separation is given, how far the objective should be placed so that you obtain the final image at least distance, at distinct vision, at infinity. What is the magnifying power of the microscope in each case? Come on, my dear students. This is the next question coming up on your screen. Yes. How are we going to solve this particular question? Okay, cool. This is the principal axis. This is the objective lens. This is the eyepiece lens. Okay. And you want the final image at the least distance of distinct vision. So see, the final image you should remember is always inverted, This is your final image. It's somewhere over here. And you want it at least distance of distinct vision. That means this is 25 centimeters because this is where you are going to place your eye. This is where you are going to place your eye. Okay. The actual object might be somewhere over here. The actual object might be somewhere here. We don't know where it is. It will form an intermediate image. It will form an intermediate image somewhere over here. It will form a somewhere intermediate image. This is image 1, intermediate, which becomes object for the second refraction of the eyepiece lens. So the objective lens makes an image here, which becomes an object for the eyepiece lens. That object creates an image over here. Is this absolutely clear? Thank you for all the love. Stranger Bulch. Yes. Yeah. Okay. Now, uh, what will you do next? Observe carefully. Hmm. Objective lens 2 centimeter, eyepiece lens 6.25 centimeter. 2 centimeter and eyepiece is 6.25. Eyepiece is basically 6.25 centimeter focal length, and this is just 2 centimeter. That is also given to you. Okay, that is also given to you. What you will do, apply the lens formula for eyepiece lens and see where the object should be. Yes, apply the lens formula. 1 by V minus 1 by U is equal to 1 by F. The image is formed at 25 centimeters on the negative side. Object I do not know. The focal length is on the positive side, which is 6.25. Is that right? For this lens, this side is negative, this side is positive. Making sense, everyone? Can you quickly tell me what is the answer that you get? Can you quickly tell me what is the answer that you get for the object distance over here? Quickly, guys. Yep. Come on, do that. 6.25 is 12.5 by 2, which is 25 by 4. Okay, so I can also write this as, therefore, 1 by U is equal to minus 1 by 25 minus 1 by 6.25, which is minus 1 by 25 plus 25 by 4. Just check this out. So this will be 5 by 25, which is 1 by 5. That is 1 by U. So U is minus 5 centimeters. Just check this out. U is minus 5. Just check this out. Everyone? Yeah. Sir, final image behind the objective lens. It could be behind, it could be ahead. Forget that. Don't worry about it right now. Don't worry about it now. Has the distance between them given? 15 centimeter. Okay, the distance between them is 15 centimeter. Okay, fine. So in that case, technically I should show this over here. This is the final image, and this is 25 centimeter, because the separation between them is 15 centimeter, because this distance is given. Can you see this? This distance is given as 15 centimeter. So I'll just put 15 centimeter over here to show it properly. Otherwise, I mean, it's understood. Okay. Now, once I get this, again use the lens formula. 1 by V minus 1 by U is equal to 1 by F, but for the objective lens. Where is the image going to be? Think about it. If the object is 5 centimeters, if the object is now 5 centimeters behind the eyepiece, for the objective, how much ahead will it be? Think about it. If this is now what we found out to be 5, how much will this be, guys? Quickly think. Where will the image be formed? This is 15, this is 5. Obviously, this will be 10, isn't it? The image is formed 10 centimeters ahead. The image is formed 10 centimeters ahead. So we will be basically plus 10. Object distance, I do not know. Focal length, I know, which is 2 centimeters. Just check this out. Everybody with me? Everybody with me? Very good. Very good. Again, apply and tell what the object distance comes out as. So 1 by U, if you take it on the other side, it will be 1 by 10 minus 1 by 2. So guys, this will be 10. 1 minus 5, which is minus 4 by 10, which is 1 by U. So U will be minus 5 by 2, which is minus 2.5 centimeter. So the object is 2.5 centimeters in front of the objective lens. In front of the objective lens. That is the first answer. Everybody got it? Very nice. Now, lastly, they also ask what is the magnifying power. They also ask what is the magnifying power in each case. Okay, what is the formula for magnifying power? Magnifying power is magnification of the objective multiplied by, if it is at least distance of distinct vision, it is 1 plus d by focal length of the eyepiece. So, objective objective lens magnification, V by U is the formula. V by U. Yes, this formula was just V by U. Use these V's and these U's for the objective lens. V is 10. U is basically magnitude wise 2.5. I'm just interested in the magnitudes, that's all. Into 1 plus 25 by the focal length of the eyepiece, which is 6.25. Just check this out. 10 and 2.5 becomes 4 times 1 plus. This is going to go 4 times 1 plus 4 is 5. 5 4s are 20. So magnifying power is going to be 20 times. Is that clear? Only get the mod values. Only get the mod values. That's all. Very good. Awesomeness. Now, for the next part, do the same thing in repeat mode. Do the same thing in repeat mode, but this time things are slightly different. Things are slightly different because this particular image, which is there, this image has to be formed at infinity. So image at infinity, reason is it is given in the question. The image has to be formed at infinity. This is the second part of the question. So how do you do for that? How do you solve the question for that? Think about it carefully. If the image is at infinity, that means this will be 1 by infinity, this will be 1 by u, this will be 1 by 6.25. So it's obvious that the object distance will be the focal length, which is minus 6.25 centimeters. So that is the object distance naturally. Is this absolutely clear, everyone? Very good. So we got this much as 6.25. Can you now guess if this is the object for the eyepiece, the image for the objective, that means this much distance, will be 15 minus 6.25, which is 15 minus 6.25. Come on, guys. Come on, guys. Everyone. 8.75 8.75 centimeters. Just check this out. 8.75 centimeters. Yeah, very good. Awesome. Awesome. Now, if this is 8.75 centimeters, now just again use the lens formula. Yes, again use the lens formula, which is right over here. 1 by 8.75 minus 1 by u, object distance I do not know, is equal to 1 by focal length. Okay, so 1 by u will be, take this on the other side, 1 by 8.75 minus 1 by 2. Yes, just do the math and tell me how much are you getting as the answer. Just tell me how much are you getting as the answer, guys. Come on, do the LCM. 2 into 8.75. Here you will have 2 minus 8.75, that is 1 by u. Therefore, u will be 2 into 8.75, 2 minus 8.75, which is 6.75 over here. 2 into 8, 16.75 means 1.5. So 17.5. So 17.5. So how much is that object distance coming out to be? 17.5 by 6.75. How much is it coming out to be? Come on. Yes, tell me quickly, guys. How much is it coming out to be? Yep. Somebody was asking, Yugant was asking, sir, when do you use that formula L by F naught 1 plus D by Fe? That is only when the approximations are valid. Yeah, only when certain approximations are valid. Only then you can use that, or else you cannot use that. When you know the object is placed at the object focal length, the image is formed at a certain place, the length focal length of the eyepiece is much larger than the focal length of the objective. All those things should happen. The image should be formed very close to the eyepiece. So many approximations are there. Hmm. How much is it that you are getting, guys? 2.5, 2.59, 2.6. Okay, approximately 2.59, which is 2.6 centimeters. Yes, approximately 2.6 centimeters. Yes, with a negative sign. So 2.6 centimeters in front of objective lens. In front of objective lens. Now, finally, what is the magnifying power? Finally, what's the magnifying power? The magnifying power is magnification of the objective, which is again V by U formula, multiplied by, since image is formed at infinity, it is just D by Fe. 1 plus D by Fe comes for least distance. D by Fe comes for normal vision or infinity image location. Yes, D by Fe. Remember, simple microscope is a D by Fe. When you see the image very far away, when the image is at least distance, the magnification increases and it is 1 plus D by Fe. So this will be V by U. V is, what is it? V. 8.75. Yeah, 8.75. Object distance 2.6. Everything is in modulus. Multiplied by 25. Focal length of the eyepiece is 6.25. Yeah, do the math. I think this will be 4 times and this will be also something number of times. Just check it out. How much is it coming out to be? Yeah, just check it out. Approximately, I'm just doing it on the calculator. 8.75 divided by 2.6 multiplied by, this is 4 times, 13.4, 13.46 or 13.5 approximately. Just check it out, 13.5 times. So this is the magnifying power later on. Yeah, when you keep it at infinity. So both the parts are done. Remember, this problem has to be solved in a reverse manner. You know where the image is, you find the object, and then make it the image and again find the object. So you go it in the reverse order. From image you find the object, again that object becomes the image, again you find the object. This is the formula for maximum magnification, which is 20 times when the image is formed very close to the eye. But when the image is formed very far away, the magnifying power has reduced to 13.5. Okay, clear? Yeah. So I think we have got the answers. Yeah, all these things we have got. 13.5, everything we got, I think. Yeah, 8.75. Yeah, magnifying power 20. Okay, so we have got it, guys. So this is the last question. Let's see if you guys can do this. This is the last question. Come on, guys. Full energy I want in this question. From the network shown, find the value of the capacitance if the equivalent capacitance between point A and B is supposed to be 1 microfarad. Between points A and B has to be 1 microfarad. I think you have to keep on reducing the circuit slowly, and all the values are given 8, 2, 2, 6, 4, 12 and all that. First, let me get rid of these two capacitors. These two capacitors, they are in parallel. So 2 plus 2 is going to be 4. Okay, fair enough. These two are in series, 6 and 12. So 6 into 12 by 6 plus 12. Is that right? 6 R1 R C1 C2 by C1 plus C2. Everybody agrees with this? Everyone till this point absolutely clear? Very good. So how much will this be? This is 72 and this is 18. Yeah. So this will go 4 times. So this is 4. So what I can do, I can just cut this out completely. And even this is not needed now. So this will become 4. So we just got this to be 4, and this we got it to be 4 also. This also we got it to be 4. Perfect. Now what we can do, observe carefully once we got this. Yep. Now these two are in parallel. So 4 plus 4, C1 plus C2, that is going to be 8. And these two are in series. These two are in series. So C1, C2 by C1 plus C2, 32 divided by 12. It won't be a proper number. That's okay. Yes, it won't be a proper number. Yeah, you can just keep it as a simple fraction. Just check it out. Divisible by 4. Yes, 8 times. And divisible by 4, 3 times. Everyone? 8 by 3 and 8. Okay. So let's reduce this circuit further then. I don't want this also now. And I don't want this also now. This is gone. This is also gone. This is also gone. So now just direct connection over here. So this is basically 8 by 3. So this is basically 8 by 3. 8 by 3. And this one is just 8. Yes, together it is just 8. Perfect. Now this is 1, this is 8. Okay, perfect. Again, you can see both of these, both of these are now in series. So the effective capacitance will be 8 into 1 divided by 8 plus 1, which is 8 by 9, which is 8 by 9. That is in parallel with this. That is in parallel with this. Yep. Is that clear? Everybody? Everyone? Till this point? Very good. Okay. Okay. So both of them are in parallel. So now this and this are in parallel. So just add them. So 8 by 3 plus 8 by 9. LCM is 9. 8 anyways, you can take it outside. So 3 times plus 1, which is 4 by 9 multiplied by 8, which is 32 by 9, which is basically 32 by 9. Just check it out. 32 by 9, everyone. Very good. So this entire circuit now brings down to, or comes down to, so many things have just vanished. All these things, they just went off. And now, oops, you just have one single capacitor that's sit in this line and whose value is 32 by 9. Whose value is 32 by 9. Just check it out. Yes, 32 by 9. It is in series with C and the total capacitance is 1 microfarad. Total capacitance is 1 microfarad. So I can just say 1 by 32 by 9 plus 1 by C is the total capacitance between A and B. They are in series. In series, you use the inverted formula. This is 1. I want to find 1 by C. So this will be 1 by, this is 1. It is clearly mentioned. The capacitance between A and B is 1 minus this 9 goes on the top and this will be 32. So it will become 32 minus 9 divided by 32, but that is 1 by C. So 32 minus 9, guys. Yep. Come on, you have got the answer now. Last step. Last step, 23. Yes, very good. Awesomeness. Awesomeness. 23 by 32. But that is not the answer. Flip it off. Flip it off. Capacitance will be 32 by 23 microfarad. So this is our final answer. C is 32 by 23. Yes, not 23 by 32. Yeah, 32 by 23. Understood how to solve this question? So these are the kind of numerical questions. Every time you simplify it, please redraw it in the exam. Don't be a hero. You are not a hero. Please don't say, I can do it. I say you magically. No, don't do that. Don't do it in rough work. Please redraw the circuit. Redraw the circuit. Oh, I have combined them, combined it. So that is easier for you, for the examiner also to give some step marking. Okay? Don't lose that step marking. Amazing. 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 We have solved this, and yes, we have got that same answer only, 32 by 23. Perfect. So did you love the class? This is how the paper has to be solved, and we have taken good time. Properly we have solved the paper. We did not leave anything untouched. Properly we have solved every single thing in the paper. This is how I conduct the classes. If you feel, this is how you want one more lecture, more classes, please let me know in the comment section. And are you game for numericals, assertion, reason, and more case studies? Tomorrow, live classes, morning also and in the evening also. Yes, morning also and in the evening also, we'll have some live classes. Is that okay? Cool. Let's meet then tomorrow. Please like this session, share this with everyone. I want every student to subscribe to this channel. PDF will be uploaded very soon by tomorrow morning. Okay. Yeah. Bye bye. Take care. Have a great time. Hasta la vista. Yeah. Thank you. Love you all. Love you all.